one window. Okay. So here is it's coming. I'm just looking at the README file since we are just reviewing whatever we did. We have already installed and tested SNO system. We need three types of linguistic sources. We have them. We have one text for Assamese number recognition system. We are just copying it both for testing and training. And these are the typical inputs of this particular text file that's required, the MERA file and wave files we already know. These details are with respect to the Assamese number recognition system, that database that we have recorded can vary from one database to another database. We after the Kaldi, we installed certain things. Let me call it. We are calling it a CLST Kaldi, that is database independent. We unzipped it, and then we also looked at the then after that we unzipped one database related to Assamese number recognition, which contained the wave files and some transcriptions and so on. Okay, then we wanted to create some soft link or shortcuts to local steps and utils directory, which contains the various programs that will help us to train and test systems. Then now we went through the data preparation part. The whatever some text files were there, we just moved it, etc. The lexicon for the speech database, we put it like lexicon.txt because that is the name, the script. Now we are going to examine data preparation scripts. We'll expect lexicon.txt in etc directory. And then we executed this command, which is a shell script here. And we checked that our lexicon is okay. Then we executed this command, which generates these files. And then we executed these two commands. So we will examine have a quick look at these four scripts that we executed today morning successfully, and see what do they generate, what is the input to that, and what is the output. So the first script that we ran was this. So I will just open that, edit that file to show what it contains. Firstly, if you look at the script, it has one argument, and this is an input argument. This is what we are going to feed it input, and it should generate certain files. What are the files? It will generate a file called something. It is written here. One for the test, another for the train. So it contains information about the utterances, who spoke it, and what is the corresponding transcription. 3 columns. So let me look at that. Open that file, and I will then share the entire screen. Maybe that's better. So where am I? Yeah, I'm here. Edit. Give me a minute. I'll share the entire screen. Stop sharing and share the entire screen. Entire screen. Start sharing. And just to cover them up, I'm just going to do this. Where is my gedit? Here. Oh, the gedit is already here. Okay, that's fine. Fine. Now, this is the file, generate this thing. And what is the purpose of the file? Let me just, to generate files containing file ID, that is the utterance, speaker ID, that is the SPK, and transcriptions corresponding to all the wave files in the wave directory. So for every wave file whose file name is this, we will not only have the utterance ID, but also the speaker information in the second column and the corresponding transcription in the third column. Now, this format is not required by Kaldi, but this format will be used by our later programs to generate files in the format required by Kaldi. So this is okay. Why this is necessary at all? Because we have one input argument, which is a text file containing the sentences preceded by serial number. That sentence also I can sort of show it here, which is which is I'll just say etc numbers 80 or something. Yes. See, the sentence number is just 0, 1. Whereas if you look at the file ID, the sentence number is 0001. So we have some. Why did we do this way? Because we had 80 sentences in one file, and this file was used by recording script to prompt the people to read it, and it was recorded. So every sentence was recorded by multiple speakers. In fact, every speaker read these sentences because we were interested in this small vocabulary. Therefore, this intermediate script is necessary. But if you you don't have to use this script, you can use any script. But if you have information in this particular format, then you can skip this particular script. So this format is file ID and speaker ID and the transcription. So the implicit outputs of this program are implicit. The input to this program is this number, this file, whatever the content is shown here. It's implicit output, which means that you don't have to type it in. It will generate on its own. It will generate two such files which contain lines like this, one for the training data, another for the test data, all that. So if you just also see the conventions from documentation, if we just invoke this particular shell script, it will give you the usage with an example and comes out. That's the good habit that one does. Okay. We are already in the AS numerico. That's an assumption there. And it reads the input file. What is the input file? It is the first argument. The people who are familiar with the scripting will understand this, but even if you don't, it doesn't matter. So the variable called infile contains now this file name, this much. Okay, because that's how we know. And we are creating a zero empty file, a new file. That's why touch command is used. Now what do? We use a for loop to do some computations for each of the wave file in the wave directory. In our case, there are 640 wave files. And there's also a readme file. Therefore, I specifically said list all the wave files in the wave directory. We already have put the wave files in the wave directory under the current directory, under the numerico 21. Okay. So it lists them. So this, see, this command is enclosed with the two back quotes. Therefore, this command is run as a subprocess, a background job, and the output is stored in this list. And so this contains a list of all 640 files. For each file, the file name is taken as FF. What you do is the following. We are going to do some text processing. What text processing is best done by Perl script. If you are familiar with Perl script, you immediately understand what is happening. Even if you are not familiar, it doesn't matter. I'll just explain the essence of this. Now, if I look at this file name, and let me look at the first file. Okay? Not this. So what is the command that I need? I need the command ls. Let me just show that. So ls wave slash star.wave, I'll just look at the top one line because I'm interested in the first file name in the list that I'm going to assign to FF, and I'm going to do all this processing. Let me see what does it give. It gave me this. So you see that the initially to begin with, I want this to go slightly up. To begin with, FF will contain this information, this string. Now, what I'm interested in is I am not interested in the directory. I am not interested in the extension. I am interested in the file ID, that is the name. So that file ID, I am going to extract it. So anything that begins with capital AS and followed by dot wave. So whatever is highlighted is selected by Perl. This is the Perl regular expression and printed, and it is stored in a temporary file called temp. If you do not understand Perl, don't worry. So what right now contains is there's a temp file. It's empty, touch, and now it contains whatever I highlighted here on the terminal. So temp contains this highlighted AS00011 M001. And note that that is what I need at the first column in my file. So I'm printing the file ID in this line. I'm pulling out the file ID from the file name and doing this. Now, what I want is only the speaker ID. Now, in this, how do I know which is the speaker ID? Speaker ID is the 4-letter after the AS. Okay, so after AS, but excluding AS. So this bracket will take care of that. That after the AS, there will be 3 digits and 1 letter. Letter in Perl is word or alphanumeric, alpha A to Z, uppercase or lowercase. So what? So it picks up 3 digits and a letter, which is what is highlighted here. So which is the speaker ID? That is the speaker ID that we need. Here, look at the top here. We are going to print it here, but after a tab. So the first line, we printed this, and then we pulled out this speaker ID, which is highlighted here at the bottom left, and printed it after a tab. You see, there's a \T tab, and then, okay. Then what we need is, we need to print a tab of, we need to print the last line. We need to print a tab and a transcription corresponding to sentence number 001. Where is that? Of course, we have seen that, you see, transcript correspond to 001 is here. Now, how do I know where it is located? So I will use a grep command, GNU regular expression. I know that the sentence number is 01. So I need to pull out the sentence number 01 and look for a line which begins with the 01. Grep does that. So this is what is done in the third line. In third line, I am looking at a sequence of 4 digits dot wave. So sequence of 4 digits dot wave, if I look at the file name, it is this. Sequence of 4 digits followed by dot wave. You notice this here, \D is decimal, but I am going to pick up only the last 2 digits. I am going to pick up the last 2 digits preceded by 2 digits followed by dot wave and print that. That means right now sent ID, the environmental variable called sent ID contains digit 01, only these 2 digits, because those are the 2 digits which are preceded by 2 digits and followed by dot wave and end of the word. Okay, so it picks up these 2 digits, which is highlighted on the bottom left, and prints it here. So we know the sentence ID. That's not sufficient. Now we look in this 80 numbers 80.txt, we look for a line containing 01 at the beginning. And that's what this grep command does. It takes the in file. What is the in file? In file is this file, whose content is shown, 10 lines are shown here. It looks for that line which begins with 1 or more digits and picks up, I ignore the digits but pick up only the later ones, whatever appears after the tab. So that is written here. Initially, the line will contain digit here and then some spaces, which includes a tab, and whatever is there till the end. After the space, this entire thing is pulled out and printed to temp with a tab before, transcription, and new line, next line. Then we have processed, and then we do this for every file. So corresponding to every wave file in the wave directory, we have a line like this in the temp. Now, of course, temp is a temporary variable that I talked about. That is not sufficient. What I'm going to do is, if an old version of that file is there, I'll remove it and I will move it as with the file name, correct file name. Why do I say temp? Why not directly put it here? Because sometimes we make error. At that time, old file should not be removed, and I'll rename the temp file name as this. And of course, test data is the same as this. Therefore, we just copy the train file to the test file. End of the session. Any questions here? I think it's clear. Okay. So what we have now, we have is two files. One is this and other is this. And we already had a look at it, but let's look at this again. Since we have already completed this job, let us look at this again. I'll just print the first three lines. Yes. So it is in the format that is shown in the documentation of the script. And what you see here, so all the speaker IDs are same. It's the first speaker that is speaking. Therefore, the second column is same, but sentence numbers are different. Therefore, the corresponding, see the third sentence, the transcript of third sentence, ek no, it is there. It is sentence number 3, and its transcript is this. Any questions? I'll wait for 10 seconds. If there is no questions or comments, I'll assume that things are clear. Move on.
Hello, sir.
Yeah.
Sir, if I want to know the coding properly, then we have to learn the bash scripting.
Yes, bash scripting. Bash is necessary for anything to work with the Linux. Let me sort of put it that way.
Yeah, like in 22 line, in AS dot star, AS dot star means after AS, what is there? Everything.
Which line number?
22.
22 is this.
Yeah.
Are you referring to? Oh, yeah, here. No, see, that is a Perl command. Sorry.
Yeah.
Oh, this is a Perl.
Yeah.
So you need to know the. See, these are all bash commands for each and so on.
Yeah.
Okay, but from here onwards, it is a Perl command. So you need to know the regular expression. Little bit of Perl is necessary to do the text processing. Okay, now right. Okay, now let me come back to your question. See, the Perl, this is the command for pattern matching. For every line, it does some pattern matching. It does some text analysis,
Okay.
and it analyzes the entire. In this particular case, this command says that take the entire line and analyze whether a pattern of this type exists. Pattern is including the forward slash.
Okay.
So the line, look for pattern. So what is the line? Line is this. This line is a typical line. Look for a pattern where it begins with the AS and go and capture it till, but excluding dot.
That's right. Excluding dot.
Yes. So what you include is inside the bracket.
Okay.
Now let us look at this line, second line. What we include is the four lines. That's where the bracket is. And that, whatever is there in the first bracket is implicitly stored in a variable called $1 at the end of this Perl command. And the next Perl command, semicolon separated, it prints whatever came inside the bracket. Yes. You can have multiple brackets. It will be $1, $2, $3, and so on. You
Sir,
don't need.
actually P in $1, so set in file equal to $1. That means in $1, the actual thing will be shifted.
Whatever is in $1, whatever is inside the bracket would be stored,
Okay.
and the value of the $1 variable, which is whatever is inside the bracket, will be printed and appended to the file temp. This double greater than means appending.
Okay. And there are 3D for three integer and one and character. There is a word W.
That's right. Already. That's the yeah, yeah. That's right. Exactly.
Okay, thank you, sir.
Any other question? All right. Now let's go back to our readme file. We have generated these two files by running this shell script. We generated it and we know how the content is. And then what we did was, whatever we generated right now, that for every word in the transcription, what is the transcription? All the information, all the words in this column. For every word, there should be an entry in the lexicon.txt. This is a requirement, obviously. Therefore, that needs to be checked. Sometimes we forget. Therefore, I wrote a Perl script which will do the job. We'll just quick. I mean, we don't need to bother about this, but we'll spend 3 minutes on that. So let me just, since we are engineers and there are no linguists here, let me check the lexicon directory. There are in lexicon directory, there may be other files that may be useful later. We'll see that later. Okay. Notice that it is a Perl script now. This bash will not execute it, Perl will execute it. And minus W means if there are any syntactic error or something, do the warning. What is the purpose? If a word in the transcription does not have an entry in the dictionary, print the word. Input is this and this, and output is list of words not present in text. Okay, that's trivial. Okay, I will not go through this because this is not necessary, but I'll tell the essence of what this, because it requires knowledge of the Perl script. Essence of what it does is the following. When you invoke the file, you are giving two inputs. One is the lexical file and other is the file generated by the earlier step. The lexical file is stored in a variable called this. So now $lexicon variable will contain the content, will refer to this file, and input text that contains the transcription in the third column is referred to. What we do is, in the line number 17 is open the lexicon, read every line, and make a list of the words by splitting, and make a hash table of all the words. So essentially, this particular while loop reads the lexicon and makes a list of all the words. How does the lexicon look like? Let me take the look at the first two commands, lexicon.txt, I guess. Yeah. So if you look at the lexicon file, it has word here and these symbols here. What we need is, we just need the list of the words to have a unique list of the words in the lexicon. It is made, and not only it is made, for every word, there is a label sequence. For example, for the word DUI here, DUI is the label sequence. So for every word, a hash is contains the corresponding label sequence. So not only have made a list of unique words, but we have prepared what is that called? We have made a hash where for every word you give in the word, it can output the corresponding label. So a sentence like this, suppose, then this can be replaced by Sunya label once, Sunya label again, now label again. So this word sequence can be converted into a phoneme sequence. Okay. Now let's go to the next step. Now we will read the opening text file. Of course, this is if there is an error, then it gives warning message and dice comes out, and this you have already seen here. Now what we do is look at the input text. What is the input text? Input text is in the etc. I think it's at something. I want only first two lines because otherwise we can't see. Okay. Yes. Input text contains this, and we again chomp the line is to remove the new line that is necessary. And okay, first line is already shown here. It's a good documentation. You split them into words, and you pick up only the transcriptions. We ignore the 0th column, 2nd column, and we pick up only the 3rd column. And that's what is written here. You pick up column number 2 onwards. Okay, the split will do that. See, earlier older thing had this thing which used to give problem. That's where there was a problem. Ignore that. So what this does is to take the 3rd column in the file, all the words, and for every word there, it uses the hash function that we developed earlier and generates the corresponding label sequence. So actually it doesn't print it. All it checks is for every word here, is there a hash entry in the hash? If there is no hash entry, then it is a word which exists in the transcription but not in the lexicon. That's all it is. Oh yeah, come on here. That's it. Any questions here? I'll wait for 10 seconds.
Hello, sir.
Yeah.
Suppose there is a lexicon. In lexicon, we have some unique words and its phonetic transcription.
Correct.
And in text file, we have the input sentence text transcription.
Correct.
Okay, so suppose we are using 0 to 9, that is 10 unique words in this particular ASR system. So if it's fine that suppose we miss some words in the phonetic lexicon, transcription like 0. If we move 0, then it will show some error that there are some unknown words which is not present in the lexicon. But suppose reverse thing happened. Suppose everything is present in the lexicon, all unique words, but some extra word is present in the text transcription. Then what? There will be any error.
No, your sentence was a little conflicting. Let me put it the following way. Lexicon, let's say we have only 10 words in our transcription, but our lexicon, the pronunciation dictionary, contains 15 words, including 10 words plus 5 words extra.
Yeah.
Then there is no problem.
Okay.
Because what it does is the following. You see the if condition here. When does it print an error? If for every word in the transcript, every $W is any word here. For every word, there should be an entry in the lexicon. Lexicon can have extra entries, no problem.
Okay.
Okay.
So it will separate by the space. In this, there are some space 8, 2, 3, 4.
It's separating by the space.
So using this space, it will separate the words from this.
Correct. Yes. See this for each $W at there's a splitting here. Sorry, line number 31. That does it. Using space separation, / space means space.
programming concept, but
Okay.
I have the I am thinking about the
Yes,
internal
yes.
thing. That's why I find out.
Very good, very good. No, no, fine. Yeah, I let me not assume the parallel concept or this thing. Yes, it looks for space as the word separator, one or more space, no problem.
Okay.
And of course, we know that Linux is case sensitive, huh? That we understand. And after the ache, you put a full stop also, it will also get into problem. That's understood. Okay, that's fine. Any other questions? Okay, if not, let us go here. So it is checking that for every word in the transcription of the train, there is an entry in the lexicon.txt. That is what check lexicon per script does. And the same thing for a test. In our case, it's the same file, but in general, when we do the reporting the results, we train on train data and report the results on test data. In fact, we do cross-validation, but we will come to that later. Okay. So when a new database comes, assuming that things are in place, so far we have run one shisk script and one Perl script. One shell script is a bash script, a bash or C shell, and this is a Perl script to check that lexicon is okay. After that, we did line number 83. This is what we did. So let's go to line number 83. We ran this script. These are the three scripts that we ran. I mean, there are other two scripts. We'll come to that. Third script that we ran was this. It will generate a files of this type under the data directory. Ut means utterance, utterance ID. SPK means speaker information. Ut to speak means every utterance was spoken by which speaker, that information is written. And this is the reverse. One speaker spoke how many utterances? That is also stored. So all this information can be figured out from this file. And I am highlighting here what we just now generated, because the first column says the utterance ID, next column has the speaker ID. Therefore, we can find out the list of utterances just by looking at the first column here, first column of this particular file. If you want the unique list of speakers, you just pick up the second column. I mean, I'm used to first column, second column human, but in Perl it will be 0th column and first column. Okay. So speak can be done, and by looking at these two columns, we know that this person has spoken this or spoken by this speaker. So the third file, ut to speak here, that information can be for every utterance, we know who is the speaker. So first two columns are stored in this file. Okay, the reverse we will talk about it a little later. Reverse also can be talked, which is for one speaker, what are all the utterances that he spoke? One speaker, he spoke this utterance and this utterance. So we make a list of utterance for every speaker. There will be one line per speaker. Okay. We need to generate them, and you have to store it under data/train and some such directory. That organization is done by this. So we will first look at the script and see the output. This script doesn't require any input because the above script assumes some inputs. So let's first, anyway, let me edit this file. Okay, this is a C shell, not bash. Therefore, I split it here. It generates files needed by Kaldi for training. It assumes implicit input. It is not given. It is not given as argument to the script, but it assumes these three files. We know what these files are. And just for the example's sake, each line of this, any of these files contain These 3 lines, we know this, fine. Now, what are the files that we probably will generate? Let me just show you those files. These kinds of files under the data directory. Okay. Now, what happens is there is a at also. So these files under the data directory are generated. I have written 4 here. Maybe there are a couple of more also will come, but these are important for us for our understanding. Whenever we implement a system, nothing goes smoothly for the first time. I mean, this is common. We are all humans. We make mistakes. Therefore, when we encounter an error, we go and correct the error and run the code again. When we run the code again, suppose already there is a file called at2speak. If you have given read, write, execute permission for every file, it will overwrite. I'm slightly, I have become older, careful. I have deleted useful files because of these things. Therefore, I do not let files to be overwritten unless I explicitly tell the command that overwrite. By default, it will never overwrite. Therefore, I'm following that convention. So if there is some old version of at2speak in the directory, which is wrong, we know that the system didn't go through all right, it has to be overwritten. So I am going to remove any such files and then start afresh, clean slate. So what I'm going to do is any files under the data directory, I'll just clean it up first. That is the function of the prepare for Kaldi train. What will it do? Clean, for step number 1, clean old files directories if they are present. You remove the data directory itself. Not only data directory, but also its children. So it removes recursively and forcibly. R, recursive, F, forcibly. It removes. So entire directory is gone. Which directories? Data is gone, emptied, experiments are gone, MFCs are gone. Because we are going to start with the clean slate. Okay. So we are at the step number 1, clean old directories if present. We are always in the ASNum 21. So if let me look at the LS. There's already a data directory there. There is an EXP directory there. And kya hai? MFCC. MFCC I have not done that, for MFCC is not there. If it is there, it will be removed. Right now, with whatever is inside, it will be removed. Let's see what is inside right now by default. It has some directories. It will be cleaned out. It may contain old files. I don't want that. So I'm just removing all these directories, starting with new state, new slate, clean slate, and I'm making a directory. Minus P means necessary. I make a directory called EXP, which will be empty, which would just look like this. Let me just show this. EXP is empty, and it will also contain a directory called data/train. Well, we saw that under the data, we saw that train directory and also test directory. So we made it here. Line number 16, make those directories. Similarly, under the data, it also makes a directory called lang bigram, which we see here. And also under the local, it creates a directory called dict. Let me just check that under the data, under the local, there's a dict directory. Okay. So we create this because we are going to put files there. In this directory, data local dict, we will put the lexicon.txt, some reformed version of that. In the data underscore train, we will put some files which tells the list of the wave files and who spoke what and things like that. There's a corresponding directory for test, that's okay. And under data, there's a lang underscore bigram. I said bigram because we are using just bigram here. It's a simple process. You can always do a trigram, foregram, whatever you want. So the grammar file that is generated will be stored here. So in general, when we look at a LS in the 21 directory, AS number 21 directory, there is a data directory, and data directory contains these 2 folders, and lang underscore bigram will contain the date language bigram model, and data/local will contain a directory called dictionary, where some version of the dictionary in the format that is required by Kaldi will be generated. Who will generate this? This particular script right now we are looking at it. We will generate that. Okay. Now let us generate that lexicon first. That's the first step that we are going to do here. Please note that whenever there is a comment here, the hash, anything after on that line after the hash is comment. So this is the first executive line. See, what happens is when you write the lexicon.txt, sometimes we do write normally alphabetic order, but sometimes you forget. If there is one extra word inserted at the wrong place, Kaldi will creep. Therefore, whatever lexicon.txt, we will sort it, automatically sort it, and write it into the lexicon file called lexicon.txt under the data/local dict. So, since we already ran this program, this file should exist. Whatever file that I highlighted should exist. Let me just check that. Data/local/dict/ oh, there are 9 files here. Let me see whether the lexicon.txt hai ki nahi. LL. Here. It is there. It will generate it. Just for the heck of it, let me look at the content of that. So let me do the. I don't want all the lines. I just want the top 3 lines. Oh, okay. There was one lexicon.txt. There was also lexicon.p.txt, which has probabilities. We are not used to it. There is only one alternate. If there are multiple alternate pronunciations, then 2 pronunciations are there. The probability of each of the pronunciations will be given here. Yeah, beautiful. Okay. But this is what we said. The line number 22 on this line number 22 that is here has created this particular file. What about these other files? They are created later. Any question?
Sir, for multiple probabilities, what you are talking about, so
Yeah.
it can be used for the dialect detection.
Yes. Okay, that's right. In some let me not say dialect detection. It is, well, see, dialect. I mean, okay, let me express my knowledge of phonetics. Dialect means region dependent, where some words are more used than other words.
Yes.
Therefore, then so this probability is not the probability of different words, but this is the probability of one word being pronounced differently.
Sir, but I think dialect was the different tonal style, pronunciation style. Actually,
Okay, if you take that, then it's okay. If one normally talks of accent, but it's okay. Let's say Britishers will say pip rather than pen, but we say pen. Okay. Now it is the same word, alternate pronunciations.
yes,
That is called a sort of accent kind of thing. On the other hand, if you say jada or some other word for jada, in Hindi there may be multiple words for jada, more. Okay.
yes.
So in some region, Bihar, North Bihar, it may be this word is more used, and South UP it may be used more, and etc. That is what is called dialect. But whatever you understand.
Wrong concept then.
I mean,
Dialect and accent are both different, sir. Accent is something like two people use differently. Varies person to person. But dialect is like a social variation.
correct.
Depending on geographical area, varies. Lots of things varies. But accent depends individually.
Yes, accent can differ individually also, correct. Yes.
Yes.
And it also may depend on if you're a second language. My Hindi has the influence from my mother tongue and so on. Yeah.
Yes, sir. Yes, that's the accent.
Yes, accent percentage.
Dialect is variation. Yes, sir.
Yeah, it's okay. I mean, best thing is to look at the handbook of this thing. I wrote it somewhere. I think I showed it yesterday. Did I show it yesterday? I don't know. Somewhere I wrote it because I also That's what it said. Dialect is more of sort of preference for some words rather than other words, more geographical, whereas accent is
I
speaker
have a
dependent.
question regarding data, sir.
Huh.
Hello. Yes, sir. Sir, as we see, we collect speech data by making people read some text, right,
Yes.
sir? Sir, I have a question that if we provide them text, some as in Mathili, take for example, some people use as a helping verb, H, hai. If we for hai, we use H or hai for Mathili.
Correct.
So if we provide them a H, sir, written text as H
Uh,
as helping verb, so
uh.
how would he pronunciate as hai? Because his mother tongue is hai. He naturally he will speak as hai, but I have provided him H, so usually he will read aloud as H. How will we capture his variation?
So the best thing is not to provide text to read,
Yes, sir.
but ask him to read. See, we why do we do ask people to read these text? That is what we did. We also in Assamese number recognition also we asked people to read. Why? Because it's the easiest
Yes,
for
sir.
people. I mean, literate people reading sentences is literate. This was collected in the IIT, so students they'll read it. Our data collection job becomes easier, but
But in this case,
if
sir, we won't be able to capture the
I
variation.
I agree. I agree. So let me so the let me point out that no, there is one more, exactly we won't be able to capture the natural variation. So the
Naturally,
right
yes,
way of
naturally,
doing thing is just record natural speech,
and then
listen to
transcribe.
them, and transcribe them.
Yes, sir, yes, sir.
I agree. But transcription, listening and transcription is a painful job.
Yes,
And if you have to do it for 100 hours of speech, you will take years.
very true,
Or
very
several
true,
people
very
working. We poor research scholars are not able to do that. That's where we use the Google to give us an approximate Hindi transcription and work with that.
I'm suffering from this only, sir. That's why I pointed it out. I'm working with on this topic project only.
You
Speech
are working
transcription.
with the
Speech Mathili script, speech transcription, sir. Yeah.
okay, okay. So I mean, the right thing is if you can get some help from somebody or something, listen and type it in. And, okay, first thing that I do not know how close Maithili is to Hindi. I mean, what one possibility is you feed in your Maithili to the Hindi Google ASR and it will type out some things. I don't know whether how words are different or not. Then somebody listen to it and just correct the transcription. Sometimes it is maybe quicker, but sometimes it may be simpler. Just listen and type it in. But there is other problem that happens when you people speak. What is that? Speak. Okay, okay. क्या है? You should write speak, but I spoke speak. These are called natural. These are called speech disfluencies. This happens. Happens. What is this? Happens. These are called speech disfluencies. This happens in natural speech. If you want a good speech recognition system, it should be captured. So when you come to the lexicon, we'll talk about the speech disfluency also. But that is much more makes it much more complication. But if you have a new language, you have to do that. I know there are people working with the Adi language. There are people working with Paita language. There may not be any dictionary. There is no ASR. You are the first guy who is building it. You make the lexicon, transcription. That's why you get paper. I mean, that's why you get recognition by the community. Let's put it that way.
Yes, okay, sir.
Hello, sir.
Yeah.
And one more thing, here we are building ASR on digit recognition system. So naturally in the dictionary, there in a particular sentence, we look for it is a permissible word, next word is permissible or no. That means I am going. So I am mango, that is not a permissible. And so for such kind of things here, every digit is permissible. After
Correct.
one, two can be, three can be, any digit can be
Correct.
happen. So,
Correct.
what is the purpose of the dictionary or such kind of bigam and trigam here?
The dictionary, yeah, in this particular case, bigram would be is of no use. What you say is right. The grammar has no role to play because any digit can come anywhere in this current context. However,
Yes.
look at the natural numbers. You ask somebody to speak his mobile number. He will never begin with 7 because 7 is reserved for defense or something. He will never tell his defense telephone number. So there are certain, and there are, whenever something begins with the 0, it is a ISD code. When something begins with 1, either it is either a 3-digit or 4-digit number. So there
Okay.
are some rules even.
Okay.
That will be captured by bigram.
Okay.
So we are using bigram because right now it is called ergodic model. Any word can come after anything, any word, equal probability 1/10 because there are 10 words are there. But in natural sentence, we are going to look at natural sentence. Therefore, we need a language model. So the Kaldi has provided language model. We are not using it essentially in this particular number database because we have. I designed these 80 sentences intentionally to see that every word, every digit pair occurs at least once. There was a reasoning there. Okay. Yeah, okay. Grammar doesn't play a role here, but we'll still go through the grammar process.
Okay. Okay. Thank
Lexicon
you.
is necessary. Lexicon is necessary. What we have done
Yes.
so far is necessary, but the grammar creation is redundant. Okay.
Okay. Thank you, sir.
Next question. Okay. If there aren't now, let me see. Oh, we were prepared Kaldi. Okay. So we are at line number 22. We generated lexicon.txt that will look like this. From the lexicon.txt, some others are also generated later. We'll bother about it later. Now, next line, we will copy this particular file that we had generated just now, which is there in the etc directory. We copy it from there to the train directory, data/train. This is a train, we copy to data/train. Similarly, the next one is test, we copy to the data/test directory because we are going to process this particular file in the data.txt, and in the data.txt we expect some files called text, art, and so on. We'll talk about it. Okay. Now let us process the files. We process the files first in the train directory and then repeat the process in the test directory. So let us do that. Let's go to the train directory. Now we have moved out of AS numerical 21. We have moved to data/train, and we are creating a file called text. What text prints is the 0th column and the 2nd column. This is a Perl script, so don't worry about it. So let me just look at the content of this. Okay, let me just print the top 3 lines. Head -3. This is in data/train and at underscore stk. Okay, let me see that. Okay, we are familiar with this content. So what text will contain is this and this without the middle column. So there is a Perl command which prints the 0th column and column number 2. So it will contain content of all this and this without the middle column. That's it. That is the content of the text file that Kaldi demands. Okay, command. The comments are here. An example line is like this. Let me see whether it is actually there. So in the data/train, I should have a file called text. Yes, that's it. So text contains essentially this, but without the column. Okay, and as explained here. Fine. Now we need to generate a file called at. What does it contain? It contains the first column of the text file. Text file contains this, only the first column, therefore it will contain only the file IDs. Utterance is file ID. Let me just check whether it has been created. Yes. Fine. Now, where did we created at? You see that I have overwritten here. If at exists, it has to be overwritten. And that's why there's an exclamation here. That's the scripting command. Now we will create a file called SPK. Obviously, SPK information is here in the middle column. But the middle column contains lots of SPKs. 0, 1, 1 and occurs repeatedly. So what we'll do is we will take the 0th column, column number 1 of this particular file. This file, let me make it. Okay, which is the file? The file is train.txt, whose content is here, and we are printing out the column number 1. This is column number 1. We will print it to some file called SPK, but there is no sorting. Okay, so the above command creates a file called SPK that contains the second column of this file, which is speaker ID. All these lines. Okay, now we need to create another file which is called at to speak, that tells this utterance is spoken by this guy. So only the column number 0 and column number 1. And so that can be done in 2 ways. One, we already have an at here, and we created a SPK, this column. So the file called at contains only the first column of this file, whereas the file called SPK contains only the second column. You can use a command called paste, which will paste the content of this and this side by side. So this file at to speak contains the first 2 columns of this file. So if there are 640 files, there will be 640 lines, and the lines, each line will contain just this. We can and of course it does some sorting that is necessary. Again, Kaldi demands sorting. So let me see the content of this file. What is the file? At to speak. Yes, that's right. Let me look at the tail, the last line. Last. It is for the speaker. This guy, female speaker, she spoke this. And okay, so. And how many lines are there? There will be 640 lines, because 8 speakers into 80 sentences. Fine. So at to speak is done. And now generating the reverse, speak to at. It is Kaldi guys have already provided a Perl script which will do the job. Just let us look at the head of that speak to at. No, that is going to be, I don't want head. It's a long line, therefore I will print only the top 1 line, and I'm going to expand it, because you see here, this is the 1 line of the file SPK to at. It says that the speaker number 011 male has spoken all these 80 files. This is actually 1 single line, and this will contain 8 lines, correct, 1 for each speaker. Any questions? It's trivial. That's okay. Kaldi demands this. Fine. Then now I'll go back to my original at to speak input file. Then we will put only the transcription, column number 2, to file called trans. We take it from the file called text. What does the text file contain? It is the data slash. I have not changed my directory. That is why it is doing this. So line number 45 next, I picks up the anything column number 1 onwards, it prints into a transcription. Therefore, transcription will contain only this last column. Let me just check that it is a trans, right? Yes, obviously it contains only that. And then what we need to do is we've created a text file which actually contains the file ID and its transcription. But Kaldi demands it in slightly different way. Or I shouldn't say Kaldi, it is the language model generation script demanded this different way. What it says is that every utterance will have a silence at the beginning and silence at the end. So the transcription should contain a symbol for silence here and a symbol for silence here. Silence symbols can be same. And that is added here. You see, S in angular bracket says that a silence at the beginning of an utterance, and /S says that is the end of the silence. Silence at the end of the utterance, end of the wave file. So this is demanded by the language modeling programs, and we store it in the language model.txt. So since we have already run this program, let us just check this content. What is content? lm_train.txt. Transcription contained only this, but lm_train.txt contains a beginning silence and an end silence. You see the slash here, end silence. This is the HTML format, and language model generation program expects this as the input file. Any question up to this? Okay. So we have generated the files for acoustic model training and files for language model training, and of course we have to repeat the same thing for the test data for decoding purpose. But otherwise, okay. Now, otherwise done that part. One part is done. Now we need to process the text files or grammar files. What grammar for text? What are the files that will be required for grammar generation? Lexicon.txt, and these grammar guys also require us to generate certain files called extra phones.txt, speech displacencies, extra question.text for decision tree. We will not bother about it right now. We will continue at the beginning. Okay. Now, there are some requirements of this lexicon.txt. So let me look at now which directory we are in. We have moved to the data/local/dictionary. Let me just move it there also so that I don't have to type in all the time. Data/local/dictionary. Okay. When I touch command creates an empty file. These two files it will create. In fact, if the file already exists, it doesn't do anything. It just shows that file is revised. Edited time is taken at the current time. That's it. But if the file doesn't exist, why the file doesn't exist? Because we had cleaned up this directory. So therefore, this file did not exist. We created an empty file using touch. For the lexicon.txt, there are some requirements. This file should necessarily contain 2 entries. These 2 entries. This is a requirement of the language grammar generation software. We just do that. So what we do is we will use one perl command to append these 2 lines here. But before appending, what we do is we rename the old lexicon.txt as original lexicon.txt. This is my convention. I always keep an old copy, and to that line I just append to these 2 lines. What are the lines? Because lexicon.txt demands this. That's so far. Whatever is highlighted here is done by line number 71 to 73. And then there are other requirements. Many times we forget it. That's why I have automated this checking purposes. Lexicon file should not contain this or this. Lexicon.txt should not have duplicate lines. What do you mean by duplicate lines? One word can have multiple pronunciations. That is okay. That is not duplicate because the second column changes in the lexicon.txt. But sometimes by mistake, we write duplicate lines. They should be removed. Secondly, lexicon.txt should not contain any empty lines because guys crib later. Therefore, that's what we are all doing. We are just ignoring any duplicate lines and empty lines, etc. That is line number 74 does. You don't have to. So you associate the comments that is written here in blue with the next 4 lines. Okay. Fine. Now, if I look at the lexicon.txt, it will not have duplicate lines, it will not have empty lines, and so on. Let me just check that lexicon.txt. But it contains these 2 lines as we need. And it has been alphabetically sorted. We added these 2 lines, but we sorted it. Okay, that's where it is here. Sort unique. Well, sort it must be somewhere here. There's a sort here. Okay, it does it. And then we also need to create line number. Now we'll go to line number 75. We also have to create a list of phones in this language. I shouldn't say in this language, in this database. What are the phones? They're all here in the lexicon.txt. They are in the column number 1 or the second column or column number 1. So we pull out all the symbols here, make a unique list. Line number 75 does that. It pulls out column number 1 onwards and sorts it, makes a unique phone.txt. It takes lexicon.txt as the input, pulls out all column numbers 1 onwards, that is only these symbols, and sorts them and makes a unique list of phones. So let me see that list of phones. Let me do a head of list of phones, that is phones.txt. You see that there is a word called A. There's also a word called, can you guess what this word is? AA is A. What do you think AAN is? Suffix N. Nasalized. See, in Hindi, how is Pach pronounced? Panch. It is Panch. Pan. Okay. In Marathi, it is Pach. Normal A. But in Hindi, so there is a not just AA. AA is here in art. But this A is nasalized A. So in the list of phones, not only A is there, A and Is are there.
Sir, in Bengali it should be Pach. In last here will be CH.
Yes. Here there will be CS. Correct. This is Assamese. Probably they pronounce it a pass.
Yes.
Good. Yeah. Right. Exactly.
They pronounce in place of saw, they pronounce chaw. We say Sonu Nigam, they say Chonu Nigam.
Cha. Yeah. Okay, right. Yes, there are language dependent rules. Although scripts are similar, there are language dependent rules. Correct. Yes. I mean, if you, okay, leave it. That's fine. So, number of phones, I can check how many word count this WC command gives a number of phones. There are 16 phones. There are total, if I look at the lexicon.txt, there are 10 or 12 lines. On the second column number 2, column number 1, let me call it as column number 1. This is this column. Column number 1, there are 16 distinct symbols. How do I know 16? Yeah. Okay. So I have created a phones.txt and I have created a lexicon.txt according to what those guys demand, grammar guys, and the grammar guys or somebody, Kaldi demands a list of the phones, out of the 16, some phones correspond to silence. Let me just check which phones correspond to silence. There's a word called, is it still here? Still is a symbol for silence. And these Kaldi guys require a separate list which does not contain a silence. So that, okay, say grep will take care of that. That's also created. So what, yeah, there's an explanation here. The last two commands, these two commands create phones.txt that contain a unique list of all phone level labels that are present in the column number 1 of lexicon.txt, and a non-silent phone.txt that contains a list of all unique phones excluding SIL. Therefore, it will contain phones.txt contains 16. Therefore, non-silent something will contain only 15. You can see that. Fine. These are requirements. We will not worry about it. And somebody said there can be cough sounds and things like that. This speech, you can add it. You can add it to non-silent phones.txt. We are not bothered about it. We will not bother about it. Fine. Secondly, two more, please. These are required by Kaldi. It requires something called silence phone.txt. It just should contain only one line. This also should contain only one line. There are variations. We will not bother about it. So these files are, the two files are needed by Kaldi. We'll create it and done. Okay. So how many files are there right now in the, where am I? I am in the dictionary directory. And in the dictionary directory, how many files are there? 9 files. Not just lexicon.txt, but ori.lexicon.txt, various things. Don't worry about that. Any question up to here? No. Okay. So now the script ended, exit. When it exits, it's go back to our number AS numerico 21. Let me go back there, and I'm still in data. See, that's why I did the PWD. I get confused. Of course, here it shows, but I'm little careful because I made mistakes as well. PWD. I'm in num 21. Now since there are no questions here, let me close this. Let me close the check one. Let's go back to readme. So we understood this. Okay. The above script assumes the following. Of course, that we have. Sorry, Kaldi train. Yeah, this is what we did just now. It created files such as this. Fine. Now, let us do the other two things that we stopped at this particular point. Let us look at this script, and then we will take a small break. First script we look at is create wave.scp. In Kaldi, there are files called script files, which will be processed by parallel shell scripts. Therefore, it is called script file. Its extension is .scp. SCP is an abbreviation for the word script. It will create that, and Kaldi demands that, and that is created by this shell script. Let us look at that shell script. Where is the shell script? It is in the current directory itself on the lower bottom. So let me edit that file, create wave script file. Okay, just let me know. All right. Now this is written by somebody from Bash itself. The guy who wrote to us, Abhishek Day. He was a project staff at IIT Guwahati 3-4 years ago, and I edited to suit our AS number recognition system. Okay. Now, what is the goal of this file? To create wave.scp file for train data and test data. What is the input? UT is necessary. Let me just have a look at that UT file. Let me just show the data /train/UT. Yeah, it just contains the utterance, file IDs. What are oh, it's also written. UT contains the names of the wave files without the extension. And the following is an exemplar line of that. Okay, we also saw that. Output will be wave.scp file, which will be there in the train directory as well as test directory. And wave.scp contains a list of the wave file and its full name with absolute path. What is absolute path? At provided the ID, that's okay. And in the column number 1, this is 0th column. Column number of the wave CP contains the entire path, because when this is processed by system, they don't talk of relative path, they will take they want, because this can be processed even in the cloud, or I don't know, whatever it is. Therefore, they need a path that begins with the slash. So in my older case, it was Samudra Vijaya, therefore you see various things were there. Okay, this is the convention. But now we see that our paths are slightly different. It will become slash home slash chief slash Kaldi or something. It will become, that's okay. We see that. This is the required output. Okay. Let us do the for train. This is very small. This is the line that is for the train data and the rest is the test data. So let's just took at this point. Wave path. Where the output should be stored, input will be where the wave files are stored. Wave files are stored in the present working directory slash wave. Present working directory is here, and under that there is a wave directory. Where is the wave directory? Yes, that contains the wave files. Data path, where the output should be stored, it should be stored in the data slash stream, that we know. So these are defining two local variables, and this is the single line command which does the job. Now, it takes the UT file, which is like this. It contains only one ID, and feeds, this is the piping, feeds to the another program called awk. Awk is similar to Perl. Somebody wrote it, so I'm just using it. It is useful for processing column, tabular information. What it does is it first in the first column it writes wave path followed by a slash followed by the file ID, which is shown here, and it also adds extension dot. So essentially, starting from here, it prints this first, and it prints this entire thing, where the file, this file ID is preceded by the wave path, which is given here, and followed by slash, and after the file ID, dot wave is here. So essentially, lines of this kind is generated. Where it will be generated? It has to be generated in data slash train. Okay, let's look at that file, whether it has been generated. So what is the input to this program? This is the input to the program. What is the output of the program? It is a file called wave.scp. Wave.scp. SCP is for script. Yes, it contains. Yesterday night, I installed Kaldi afresh here in Kaldi. Earlier, it was under desktop. Now it contains here. Now it's running. Any questions here? All right, so that was trivial. So it's just this is the file that will be taken by Kaldi MFCC, signal processing, null frequency coefficient will be computed using starting from here. Okay, let's go back to README. The next one, where some of us had problem, was this. It creates a grammar file language model. Which language model? Bigram language model. And this is a shell script. Let's look at this shell script. It gave lots of messages and sometimes error to some people. One person still had problem. My suggestion is do what I did, reinstall Kaldi, think it will be all right. It happened to me. Okay. So let's look at this file. Edit, create bigram language model. How many lines are there? There are lots of lines, but I'll tell you the essentials, rest we can sort of forget. Generally, and this is also a bash file. Okay. Generally, I put a date at the beginning and at the end so that I know how much time it took. It's a sort of my portion of practice. It
Hmm.
defines some training dictionary. Yeah.
Sir, I reinstalled the Kaldi today only, but I'm getting same error that got yesterday at this 95 number line, sir.
Okay. We will address that at the end of today's session. Yeah.
Yes, sir. Yes.
My guess. Did you change 1.7.2? You did that,
Yes,
is
sir.
it? There is some clash
Yes, sir.
somewhere. You see, whenever we install, we should also the output should be put into a log.txt and check for any errors. Sometimes it happens. I don't know. We'll see that later.
Yes, sir. Yes.
Hopefully, I will be able to solve it. But let us see.
Yes.
All right. Now, this what is the file? Create bigram language model. It runs the command dot shell. See, if you look at the terminal output here, there's a cmd.sh. कहाँ है? Yes, cmd.sh. So this is something that has been provided to you by Kaldi guys themselves, but slightly modified. Let me see what it contains. It contains whether you are using GPU or not and things like that. So we ignore that. We are all using CPUs, no CUDA and all those things. We are going to use a run.perf. No cluster option. Forget it. It will run that. And it also checks whether there's a path. If there's a path.shell, then execute the path.shell. Of course, we looked at this path.shell yesterday. Let's see. And we changed this one number also here. But this path.shell was is also almost standard, except this particular part. Actually, we added it. We means at IIT Guwahati, and I changed this number also. Something, ignore that. Don't worry. Now, and where is the dictionary? What is the name of the dictionary file? It is dict. What is the name of the output language file? It is language background. In which file the training data, etc. information is there in trait. These are local variable, don't worry. This line number 15, says it where we are going to use a bigram, n-gram equal to 2. There should not be any space on the left side of equal to or right side of equal to. This is the bash convention. Okay. Then it's our echo means print messages. Training and n-gram language model. Any old stuff is there, it removes it. It makes a necessary directory. We'll just quickly run through this. It prepares a language model, and then what does this language model shell takes? It takes dictionary as the input and generates the okay. It takes the dict in the data/local as the input and generates some file, and that same file is used by the next command, build language model.shell, and it generates a language model, but it is gzipped. That's what they do. That's the sort of big language models can be stored efficiently. And then there is a language model that is called ARPA language model, Advanced Research Project Agency in US, 3-4 decades ago, old story, that generates the language model. And it checks whether there is any out of vocabulary words. But we have been smart. We have done the check lexicon.pl, and we have ensured that there are no OOV words. So if there is OOV words, though wave files whose transcription contains such new words which are not there in the pronunciation dictionary will be just ignored. That's why they are doing all this checking. So OOV means out of vocabulary. Okay. And it generates, now this is the big command. Lots of pipes are there, means it does various checkings and so on. And it does the finite state transducer compile. It compiles a finite state transducer, which is a graphical language model. And of course, it's not just that it does various commands. At the end, generates this file. And g.fst, it also checks that whether g.fst file that is generated is stochastic or not. Is the finite state transducer, is it stochastic? So when you run the create this script, it says it is stochastic, it is not stochastic. That is the output of this particular line. But actually grammar, it is called capital G for grammar, FST for finite state transducer. It's a binary file, so we can't read it. But it is generated at this line last. Any questions? Where is it generated? It is generated in the train data. It will not touch the transcription of the test data. Obviously, it is not supposed to know it. So let me just look at the file, whether the file exists. Of course, our messenger said that it exists, but let me check. Where should it be? It should be the data/train language is train g.fst. It is not train language, it is some other language. Lang.background probably. g.fst, yes, it is there. Is it a text file? Let me check the nature of the file. File command gives me the nature of this particular file. It says that this particular file is an open FST, open finite state transducer. That is a open source grammar generation program, OpenFST. It's a binary file. It contains finite state transducer data, and what is the type of the object? It's finite state transducer is a vector, archetype, standard, version number 2, number of states is 12. Something. So we have done up to here. Any questions? I will wait for 10 seconds. Nahi hai. So let me just go back to my README. We have done up to here. Well, one person still has error, but we'll see that later. But otherwise, at least 4 of us have had no problem. Then the last step is this. We'll do this, and then we say, data preparation is over. This will take a little bit of explanation, 10 minutes. We'll take 10 minutes, and then we'll take a 10 minutes break. Now, the last thing is, okay, let's look at where am I? I am here. What are the files which are there? These are the files. And I see a folder called conf here. Let me see the content of the folder called conf. I'm going to list that content. You will see 2-3 types of files. Let's look at the extension. One is called configuration file. Another is called just conf, another configuration file. Third extension is proto. Topologies or prototype. This is the HMM topology. And there are 2 files with the extension config. One is decode config. One is decode with the deep neural network config. We will not bother about that. We'll keep quiet. Let's start with the default one. But let us look at the files with the extension conf. There are 2 types of files. One begins with the fbank. Fbank is filterbank.conf. Other begins with the mfcc something.conf. You see mfcc underscore various sampling frequencies. What? Give me 10 seconds. The sampling frequency of our wave files is 16,000 hertz. How do I know? Well, I can check using the file command. If I look at the one wave file, let me say 010, capital M probably. No. 645, nahi baba. 011, 0010. Okay. There is one file. And just look at the content of the one file. or what kind of file is this? It says that wave audio 16-bit, mono, and 16,000 hertz. So if you take a new database and you don't know what is sampling frequency, whether it is 16-bit, whether it is mono or stereo, and things like that, that can be found out by doing a file command. Okay. So there are 2-3 questions. Yeah, please ask.
Hello, sir.
Yeah.
Sir, suppose we make a model with some particular frequency, say 16 kilohertz or 8 kilohertz, but if there are some file present which is the which with a different frequency, suppose we are going with 16 kilohertz and there are some file of 8 kilohertz, then there will be any problem in
Yes.
efficiency or
Yes. No,
execution?
not efficiency. Your program will not run. I mean, Kaldi expects all the files to have the same characteristic. That is, all the files would have been sampled at the same sample frequency, and all the files should be mono, not stereo. All the files should have been the same bit, 8-bit or 16-bit. That is okay. But entire file, whether it is in train data or test data, should have exactly the same characteristic. This should not change.
And I got a article, and there they have do some work, and in 8 kilohertz, suppose they got a efficiency of 10%, and but for 16 kilohertz, their efficiency increase, suppose 1% or 2% increase. So
Now, one minute. See, there's a difference between when we are talking of that. They might have recorded it under 16,000 hertz. They downsampled it to 8 kilohertz, and the accuracy is lower. In general, accuracy increases. Accuracy is better with 60,000 hertz. That's understood because there is more information.
yeah, but it will take much more time to execute because
No. 16,000 hertz. See, the execution time is only in the MFCC computation.
Yes.
That is 1% of your execution time, because lot of time takes place in decoding using HMM, not signal processing.
Okay.
So if you have the option, record it at 16 kilohertz or 44,100 hertz, it doesn't matter. You can always downsample. You can reduce the sampling frequency. You will not lose information. You will lose 1 parts in million information. It doesn't matter. But if you record in 8,000 hertz and you want to upsample it to 16,000 hertz, you don't gain any information. You just are matching the format. That is not good. Next. Yeah.
Yes, sir. So actually, I had a question on the bit rate, because I had previously done a model. I tried an HMM on like a normal English number system that was using a 32 bit rate audio. So that gave a really bad model. But then after like using an online converter or something, converting back to 16 bit, the accuracy didn't change much. So is there? I mean, when you're collecting data, is it important to like set the bit rate like initially itself to 16 or?
Yes. Not necessarily. It's up to you. If you the 16-bit is good enough for most speech applications, because 16-bit allows the amplitudes to be plus or minus 2 power 15, 32,000, which takes care of SNR of something like 120 dB, 140 dB, which never occurs in real life. Therefore, 16-bit is good enough, but 8-bit is not adequate.
Okay. Okay, so thank you.
Okay, so the summary is recommended bit rate is 16-bit. That is good enough. And even if you record in stereo, you can always convert it into mono. It's a trivial one-line command. You don't even need an online thing. It's a SOX command. Trivially will do that. And when you record, do not record at 8 kilohertz. Record at least 16,000 hertz. If you want to record at 44,100 hertz, because that's the default sampling frequency of your handheld recorder. Because many times, suppose it's a Adi language, I may have to go to the village and ask people to read. In which case, I can't take my laptop. I can record only using a handheld audio recorder. Default is 44,100 hertz. converting from 44,100 hertz to 16,000 is a single one line command. SOX will do that. That's trivial. I'll show you.
Okay, sir.
But on the other hand, if you are recording in the lab, whatever is highlighted here on the bottom left is the preferred.
Okay.
And now, since we are at it, many times people see, you can coax your friends to come, 2-3 friends will come to your lab and record speech. Most people don't want to come. Who will come and things like that. So on the other hand, people are willing to use their mobile phone and read a set of sentences or speak whatever it is. Now mobile phone by default uses 8 kilohertz. This is the standard since a century. That was standard was set, not century, well, almost. Yeah. So, and it uses mu law and things like that. Doesn't matter, but 8 kilohertz. So now, of course, these days we don't use the regular landline. We use WhatsApp or through the internet data connection, WhatsApp or something, where they actually, some of them do go into slightly higher frequency and so on. So the frequency, etc., we may not have control. If we are using mobile phone, we do not have control over the frequency and the bit and things like that. But it is our responsibility to make sure that all our wave files, whether it is train or test, conform to some standard. It's the same format as it is highlighted on the bottom left.
Okay.
So any conversion you need to do it. Do it to the preferably to the slightly better one, preferably to something like this. Okay, this is general advice. Yeah, over.
Okay, sir.
Next question. All right. So yeah, let's execute these commands. Now these lines assume that it's sampling frequency 16,000 hertz. Why? Because yes, we saw this 16,000 hertz. And mono is required by Kaldi because there is no advantage that Kaldi, even if there is stereo data, it just increases the space, but Kaldi doesn't make use of it, at least as of now. Okay. It uses 16 bits. So this information that our 16-bit data, mono and 16,000 hertz, at least the sampling frequency and bit information has to be specified to the Kaldi for training, and that is specified in these two files. One is a file called mfcc.conf, another file called filterbank.com. That these two files should exist in the directory conf. So when I did the lf/conf, these two files are not there. Which file? This file and this file is not there. Intentionally, I have not put it because it is your job to put that MFCC file according to the sampling frequency. So let me look at the content of this sampling frequency file. What is the first file? MFCC 16,000. So let me just display this file more. It is in the conf directory MFCC _ 16,000. That's it. It has a format that we don't have to worry. And this is a comment. Use energy equal to false. That means when you compute the melt frequency Kepler coefficients, you do not use the zeroth Kepler coefficient, or you ignore the energy content, because sometimes somebody may speak very softly, somebody may speak very loudly. So the energy should not matter in speech recognition. That is the first line. And the second line specify the sampling frequency. On the other hand, if I do the 8,000, let me see what happens. Yeah, this line has changed. That's all, this number. Now, I don't want you people to, I have been teaching students, even editing, they make mistakes. So what I did was, when I provided the zip file, I created the various MFCC files for 16,000, MFCC files for 22, this thing, MFCC files 48, various common ones I created. And what we will do is now just providing the shortcut. So that what Kaldi looks for is a file called mfcc.com conf, and when we provide a soft link or a shortcut, this mfcc.conf will actually point out this, and Kaldi will read this file. Similarly with the filter bank. So let us execute these 4 lines and take the break. Okay, let me before that, just I want to also people to do this ls conf, and you how many files do you see? 9 plus 2, 11 files. After executing these commands, you will have 2 more files. Let's execute these commands. Now I will do the ls conf again. Yeah, mfcc.conf and filterbank.conf. Anybody got any different value? This all everybody should get, nothing to do with the bigram language model. Okay, nobody has any other data preparations over. Okay, now no, since this is notes on files created in the above. Okay, so well, these are the files that are required, and these are the files that are required. We already talked about it. Now we want to do this job. It may not take much time if things are okay, but still let us take a break. It is already 1:45. 10-minute break is okay?
Okay.
Yes, sir.
Yeah.
Okay, so do we come back at 4:55? Yeah. Okay. We'll wait. Okay, let's continue. So now most of us are ready to train and test automatic speech recognition system using the Assamese number database. Number is a sequence of digits. Now, there is a, okay, let's look at the files that are there in the directory. There is a file called run.shell. That's what we are going to use. Now let's look at all the files in this directory and let's have an idea of what these files will be used for. Command.shs, that is used for checking whether there's a GPU or not. It's a setting. Conf directory, blue color. So it's a directory contains these configuration files. This shell script is for creating the language model. Right now, bigram. If you want, you can also make trigram. And the next script, create wave.scp, is to create a script file which contains two columns. Zeroth column contains the file ID. Second column contains the location of that file anywhere in the disk. So it need not necessarily be under the wave in the current directory. It can be anywhere as long as you change the script. So you don't have to copy it from here. That's what I want to say. But the simpler way is just provide a soft link to directory that we can talk later. Then data directory, we know what it contains. Demo.shell. I also wrote a shell script. After training the system, it is fun if I can speak some Assamese number and it prints out the output. It will be wrong, doesn't matter, but at least it's a working system. So it's a demo. We can look at it later. etc directory, etc. we have already seen. Experimental directory, that will be created because that's where all the training models and various other information of the experiment will be created. Right now it is empty. Local directory is which contain local steps utils. These directories contain files created by Kaldi guys. Path.shell tells where our FST is located and so on. And then we talked about the prepare for Kaldi train.sh. We looked at it today. And now we will inspect this run.shell. Run.shell runs Kaldi training and testing. And it's a bash script. We'll have a look at that. Now, why do you want to look at that? Because in the run.shell, if suppose your laptop has multiple cores, these days some of the laptops have 4 cores and so on, then many things can be done in parallel. It can be done in, if you have 4 cores, sometimes it is possible to run. So for example, process the 4 speech files simultaneously, independently on 4 cores. And even while decoding recognition, also it helps. Therefore, you can set the value of the number of cores, number of jobs. NJ stands for job. Number of jobs, parallel job that can be set in while training and while decoding or recognition. There are some constraints here that you can read on your own. Right now, for example, how do I know what is and how many cores are there in my PC? I might have forgotten. And for that, there's a command called nproc. N processors. Nproc, in my case, will give 8. I have my thing is it has 8 cores. So you just remember this, and in the run.shell, let us edit it and set these values. Let me just show the value. Let's edit a run.shell. And now I want you people also to do this command nproc and remember the value and gedit run.shell. Let us go. We will not watch. Yeah, question.
For example, like let's say that you have 8 cores. So setting the value as 8, like will it slow down the system or something, or should we like set a smaller value? even Rustam had this doubt in the morning.
Okay. Now, when you say slow down the system, if you have some other job running, well, other job will slow down. Okay. But if you are running only this, it doesn't. Your normal commands, I mean, if you're doing video on WhatsApp, of course, both will slow down. But normal typing in, email checking kind of things, it doesn't matter.
Sir, also, like, I mean, I've seen a lot of scripts have like they set the number of cores to like even numbers. So, is even numbers is like any rule for that, or like people can just set any odd number also, like 3 or 5 or.
You can set whatever you want, provided, okay, what are the rules? Okay, let me know since this should be less than the number of cores. Suppose I have 8. In my case, answer is 8 here. I can set train NJ as 7, 6, anything, doesn't matter. I can set teacher as 1 also, no problem.
Okay. Got it, sir.
Okay, good. Now, so if you want to run some other thing in parallel, yeah, you don't mind this training process to go a little slow, reduce it, no problem. Okay. Of course, there are other constraints. You also look at the number of train speakers and things like that. That right now we'll not worry about it. Okay. Now, in fact, sometimes people even set this number greater than n core. I have 8 cores here, but in principle, it is possible to set this as train NJ is equal to 9 also. Kaldi doesn't object. Why? So then where will it be useful? Look at the following. Processing a file involves file I/O, input output. Reading a disk file from the disk takes time. So when one file is being read, another file can be processed, and therefore some people use this. But I wouldn't go that hard on the PC. I'll stick to this convention. Okay. So let us edit the file. Let me go to run.shell. It is a bash script. So it clears the screen, type the date. I mean, that's fine. It runs the command.shell. It runs the pod.shell. We don't have to worry about it. Certain things are here. We will not worry about it now. When you know the GMM-HMM well, you will understand these numbers. Now, I am concentrating on these lines, 22 and 23. I have set it as 4 by default. I can set it as 8. But I will leave it at that. Doesn't matter, because I would assume that most of your laptops will have 4 cores. All right. Anybody has more than 4 cores? Anybody is competing with me?
That's 6 core.
6 core. I see. That's a nice number. I mean, I thought it was always 2 power of 2, but it's 6 core. But okay.
It's not laptops, it's a PC. Sorry, desktop. I'm using a desktop, sir.
Yeah. Okay. Yeah. Still, NPROC will give you the number. Kitna hai?
6, sir.
6. Okay. It's a desktop, therefore 6. Somebody has put it. Okay, good. All right. Okay. So you can set it to 6. It's up to you. See, this is a small job, so it really doesn't matter much. Okay. So I have set this. I'm not going to make change, therefore I don't have to save it. But let me go back to README file. Edit the run.shell appropriately. That is the first thing. Second, what we are going to do is we are going to train the system in 2 stages. This is I'm a bit cautious, because many times I make mistake in the computation of MFCC features. Why? Not MFCC program is fine, but somewhere my file will have 8 kilohertz or 16 bit instead of 16 bits, 8 bit. I have not checked. Some file is empty. Some file has only 0.2 second duration. All these nonsense things happen. They get caught in the first process when you extract the features, MFCC features. So I want to first check that my feature extraction runs all right. Then onwards, there is no problem, because I have checked the language model train is running all right. How did I check that? I ran this. There were errors here. So these are the critical data preparation errors, and there is a data preparation error still might not have gone. Therefore, I will first step number one, I'll compute the MFCC features and do not train. If there is no error, if there are errors, resolve the errors. So that's what I'm going to do first. So how do I do that? The CLST guys have evolved something called a switch. If the switch is one, some particular stage is run. So let me go back to the run.shell. See, they said set switches. So by default, this switch is set to 1, and all training testing, all other switches are set to 0. And what you see is that you can not only do the monophone train, that's what we do for today. You can set these switches one by one, or whatever it is. And these three switches you can set correct one by one, good too, because what actually happens is most of the errors are caught here. And if there is any remaining error, it is caught here. If you can train a monophone system, running this is always trivial. Okay. And these things, suppose monophone training takes 1 hour, these may take 2-3 hours or 4-5 hours. SGMM, this stage takes probably 8 hours or more. And I'm just giving you order of magnitude. And DNN also may take 3-4 hours and so on. So depending upon your database size, you get an idea of how much time does it take to train and test a monophone system. This doesn't take much time, maybe half an hour, 15 minutes, something like that. Don't worry about that. That's short. Signal processing doesn't take time. With the training and testing, that takes time. So by running this, so what we do run is, first we run this. In the second stage, we run this. And later at home, you run this. Your accuracy will not increase much because this is a small database. Okay, that's fine. Any questions here up here? So read me. Question.
So what if we just do the MFCC and the monophone training together?
No problem.
If our database is right, will there be any?
No issues. See, the trouble why I don't do it is when you do this, lots of messages may come. I put it in a log file. I want to know whether there is an error or not. In the case of a new database, I will go in these steps, 3 steps. One, this, then this, and so on.
Understood. Okay.
See, even when you do that, actually, see, this is always done. Even if all switches are 0, this is always done. But my practical experience is that these two guys give problem. I mean, I shouldn't say problem. In fact, they are helpful to me. They notify if my data is in the order that Kaldi expects. That is why I run this independently. And when I run this run.shell, I am running it again. But it takes some 1 minute, so I don't bother about it. So in principle, if your database is very large, you can comment this in later stages, but that is okay. All right. So let me go back to my README shell. What else do I have to do? I have to set this switch 1 and all other switches to 0, and I'm about to run it and save it, obviously. Let me just check my switches. Run.shell. By default, it is in that manner. 1, all other switches are 0. So I don't have to make any changes in the run.shell. I will do only MFCC extraction. Before I run, let me see what all things it does. It is some local directory names, database dependent preparatory work, which we have already done. So, and after that, there is a date command. So there is a date command at the beginning. Therefore, I will know that my setting switches and running these commands took how many minutes? 1 minute at most. And then this switch is 1. Therefore, up to here it does. If, then finish, Fi. So if, since this switch is set to 1, these lines will be executed. What are these lines? First, it prints a command. This is my, I inserted this because I need information. I want something is going on. Otherwise, half an hour, 1 hour, nothing happens. Is it running or not? It becomes a difficulty. Okay. What does it do? It does the MFCC processing for train data as well as test data. Therefore, there is a for loop here. Once for train data, another for test data. Okay. For the train data, it uses a shell script in the steps directory. See, now the steps directory is useful. And actually, you are using number of jobs 20 here because file IO is there. Therefore, 20 files are being processed simultaneously. It will, these are all the standard things. Let's not worry about it. If this particular command with these arguments, if it fails, then it exists. So there's an or here. This is actually a single line. If you, but so this is the kind of if this fails, it should not go to the next step. Therefore, if this is successful, then go to the next step. It is, if this one becomes 0, then this will be executed because this is a or in bash. Okay. After that, once the computer melt frequency capture coefficients are computed, their means are set to 0 and variance are normalized to 1. So this process is called CMVN, captural mean normalization and variance normalization. 0 mean, unit variance. Okay, this signal processing. And then sometimes some funny things happen, which is some files are empty, some files are short, and all nonsense things happen. It checks that things are okay and validate and data. These two lines checks that everything is okay as far as MFCC is concerned. I also don't know its content, but I know the kinds of errors it throws. If it throws an error, kuch gadbad hai in your MFCC directory, something, you need to take precautions. So, and then it prints the date and it's done. So what we will be doing essentially is to execute this because MFCC extraction switch is 1. Any questions here? No. So now let me go back to the terminal. We don't have to make any change, therefore we are not facing any change. What we'll do is, according to readme.shell, you need to run the run.shell. But my general convention is I will always put the output into a log file so that I can inspect it leisurely because sometimes many things come. So let me run that run.shell. I will output, not only output but also error into log.txt. I can actually say that is mfcc.txt, but let me call it as log.txt. Therefore, it knows it's a log file. Let me just run it. Now, when it is running, your control is not in your whole. I didn't put an ampersand here, but ho gaya. 1 minute mein ho gaya. So let me just check. Let me just more this log.txt rather than. Okay, it put the date and it first does the training 2 gram LM. So all these errors messages keeps coming on the terminal. Then if there is a error message, I will not know. That's why I always, error message may be somewhere here, you may miss it. That's why I put it into log directory. Okay, 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 okay. Okay, okay. It will all be okay because we have already done this. Found no unexplainable phones, various things. Okay, 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 okay. Since we have looked at it, this one already. Okay, checking topology, HMM topology. Okay, G.fst. Okay, it took this much time. So it took this much time to do the checking the language model, and then it created the wave.scp. How much time did it take? nothing, not almost zero. And after then it started doing the abstraction. It did 20 parallel jobs. How much time did it take? This much. Let's say this is 302. It started at, so 7 minutes it took. 7 minutes? No, 7 seconds. It's a छोटा after this. Oh yeah. And now, there's an error here. Can you see this word error? Can you see this word error? So somewhere some funny character is there, unallowed UTF-8 character. UTF-8 is not ASCII. Maybe by mistake that text file contains UTF-8. It cannot contain UTF-8 character. White space, tab or something is there. So this is a little bit problematic. Can create problem. So what I normally do is to grep error with the log.txt. It will tell me, oh, there are 2 lines that contain. So then I will go and look at this. This is there. So let me just check this file once, just for my consideration. I will do a more. If I do a more, it may not show any error because UTF-8 will be without any problem. Oh, I don't know what this. I won't even know where is the non-ES. So I need to use a Perl script or something to check that. Even gedit probably will interpret the UTF characters. Let me just try this. So one of the files contains something funny. I don't know what that funny is. Will I be able to see in gedit? Probably not. Is there an extra line or some such thing? No, extra lines would have been taken care. I do not know right now. I don't see it, but so I'll assume that this is an error, not a fatal error. Let us hope that it will run. If run nahi ho gaya, so our original sum is here number.txt. We have to type it in. That's okay. We'll do that. That is not a big deal. So let me now assume that things are okay, and let's run the run.shell with the next switch. Okay, step number 2. Train and test monophone based system. Therefore, we have already extracted the MFCC. Therefore, we'll set this switch to 0 and monophone training and testing switch here and here. You see, okay. I did all these things. Log also. Okay. So let me edit the run.shell. What are the things that I have to do? These things. Run.shell. Edit it. You people edit it. Set this to 0 because I don't want to recompute and waste time. I'll set this one and then set this to 1. That's it. I need to save it. Save. Before I move on running it, let us see what training and testing does, what kind of things they do. It comes here. Oh, it just runs this. Training monophone. And since test is there, now dekho. Test has little extra step. There's a make graph. What is a graph? It's a graphical language you want to find a state transducer. Now when you test the data, you just have to run the decode.shell. That is okay. But that decode.shell will give you the output, whatever it recognized. But we want to compute the accuracy or the word error rate. To compute the accuracy, you need to know the existing, what is that called, transcriptions. They will be used. But okay, this is done for some other reason. I'll tell what the reason is. Suppose I took Assamese speech data, general purpose speech data. I have 100 hours of speech data and text from all Assamese text that I can get on the internet. So when I created a language model using training data, where is that? Here, I can use the text from any text in general purpose and build a big general purpose language data. So it can recognize 10,000, 50,000 Assamese words. But now I am going to use this data only for recognizing certain specific words. What are the words? Let us say you are checking the status of your railway reservation. You want to book a railway ticket, you want to check. You call a call center, automated call center, it asks some questions, words which are very specific. Therefore, our vocabulary is small and kinds of questions that we ask is also small. So, in actual usage or deployment, we may have a specific task. Therefore, the vocabulary size may be smaller, and the grammar types of questions that are asked, or questions or sentences that are spoken, are also very specific to the task. So, while decoding, while recognition, we want to recognize only those words and only those type of sentences. So we will rebuild the language model using only the test data, level transcriptions. So you can build a new language model and build the final state graph. Okay, that's the high level description. We will not worry about that. Okay, it does the decoding. When it does the decoding, it also computes the word error rate. But I added a word command here. You show me the various word error rates for various language model weights. Okay. So let's run it. So I have saved this. I will go to my directory and I will run. What is the command that I want to give? I want to give this command. See, now I have put an ampersand here so that even when it is running, I can check the log file. Log file is this. So let me do these commands one after another. It doesn't matter. You can put one after another also. Doesn't matter. Okay. So, yeah, question.
So what is the no HUP?
No HUP. Sorry. Okay, come on.
Hello,
Okay.
sir.
Yeah.
No, matlab,
Well, let me answer his question first.
Okay.
This is the command that we give. Okay, actually what we just need to do is dot run. Sometimes it doesn't run otherwise. This is the command that we are supposed to run. But we are going to put the output to this file, not only output, but also error. This ampersand tells that errors also should be written in this file. And at the end of the command, if you put an ampersand, this command will be running in the background. So your control returns, your terminal is free, you can type in other commands. Now, this job for a large database may take several hours, days together. And in between power failed. Then suppose you have done the MFCC computation, you spent 1 hour. You have done the training, you have spent 4 hours. Now just testing was running and the power failed. Then what if you run this command again? It will waste 1 hour in computing MFCC, 4 hours in retraining, and so on. We don't want that to happen. So Linux has a command, something called no hang up. Hang up, if you see the good old telephone systems in old movies, if you see, telephone systems are not kept on the table, but they were getting hanged on a wall. So hang up means stop. Even if the current goes, store the intermediary results in a temporary file, and when the PC is rebooted, start from where you left off. This is sort of useful for big programs, whereas whether it will be actually useful here or not, probably it is not. I'm not sure about that. Okay, so but in general, when I run long commands, I prefix it by no hop. I put the suffix ampersand. And have I answered your question, Mitesh?
yes, sir.
Okay, yeah, next question.
Hello, sir. So before, as you run run.sh, so I just run .sh without changing any value. because by default it was MFCC extraction, but now we have to change the value in run.sh.
Correct. We have to edit the run.sh. So the first one, did we run?
Yeah,
I
yeah.
don't. We ran. Yeah. Yeah,
Same.
we ran and
Same.
did the log.txt. Now edit this so that
So we can just open this file by click in that folder,
yeah.
or we have to cat.
No catting. Edit. Normal edit. Gedit or vi, whatever you like. I don't care.
Or gedit space run.sh.
Yes. Yes. Gedit space run.sh. I put an ampersand by, that's my convention, but that's okay. Gedit space run.sh. So let me just show it. Yeah. I'll close this. I'll say gedit space run.sh. In I always want to put it in the background job, so I put an ampersand. It opened here. I just go there. Yeah. These 3 lines I will change.
The in line
29. I put it as 0.
31 and 32 will be 1 1.
Correct. Because we don't want to extract
And MFCC will be 0.
0 because we have already done that job. This is a nice way of doing stage by stage.
Okay.
Once you make the change, you save.
Okay.
And then I will follow the instruction here in the README file. In the README file, this is the command that I am giving. I'll give both the, let me run one by one. Copy. I'll go to the terminal. Well, this is my, I never do a window full screen. I do this so that I can go look at here, there, and so on. Okay, I'll paste it here. I press an enter. Now, see, the first job, which are the gedit job, was done, but the second job is running. This is the job number in the square bracket for people who don't know. That's the background job number is 2, and this is the process number. Anyway, we don't have to worry about that. If you see a top or H top, you will see that something GMM alignment is happening, program is running. I'll do a quit, doesn't matter. But before that, before it completes, let me also do this job also. Let me see, keep examining the output file. So I'm going to give this job command also. Which command? This command I am going to execute it right now. Line number 148. Let me do that. Enter. It said something. No hop, ignoring input, something date it said. It is training the algorithm and all this again, it's doing it. I know this is all fine. Let me go through that. G.fst. I'm fine. Monophone training. I started. When did it start? It started at 28:16. 28. Okay. It is using 4 cores. It is initializing the monophone system, compiling the training graph using the training data, and forward backward algorithm. Expectation maximization. Pass 1, 2, 3, 4. Okay. It is doing 35. It is right now, it has done the 35 pass. It will do the 40 passes. That's the default value. And whenever this file changes, something shows up here, new version exists or something. I will have to refresh it. Let me try to refresh whether I can. Is there a refresh? No. Either, it said reload. It already said reload. So I'll reload it. Now it will show some more output has come. It has reload. Let me go down. Yeah, unfortunately I have to do this. It completed all the 40 passes. It has done the job. And for the training data, it took 1.1 hour. I don't know that. I don't understand. It has done the training and the models are there in the exp_mono. It already started the testing. It compiled the test language model. It does all the other things. And it's what error it is giving. If I go here and press an enter, it has already done the job. This particular job was done. But I'm looking at the output, it is showing. You see the word error rates here? Before I ask questions, let me just go at the end. How much time did it take? I'm interested in that. Okay. So what I will do is I'll just grab the today's 2021. I'll just grab this particular thing in the mono.txt. It will give me all the times. It started at 28:15, completed at 29:39. Kitna? 1.5 minutes. Less than 1.5 minutes. It's a small database. So signal processing and decoding and training and testing will take less than 2 minutes because this is a small database. Now these outputs are the output that is here. This is not part of the Kaldi script. This I put a command grep dot something. I'll show you here. At the end of the monophone testing, here is the monophone testing. After that, the following line was introduced so that I want to know what is the word error rate. Otherwise, somebody has to go there and check files. No, I want everything to be displayed on my terminal. It's shown up here. Any questions here? No.
Sir, when I am running this, I am getting some error.
वो error क्या है देखना पड़ेगा. Okay. Okay. Any others who have got successful, we'll come to that. But any other question by others? See, if not, we will break today. Okay. So.
Yes, sir. I have a question.
Yes, question.
So while we ran that run.sh wala thing for right now, so basically we are just doing the mono wala thing, right? So uska after we ran it, we got some WER ka rate. So
correct.
So we actually trained our acoustic model, right?
We trained our acoustic model. We
Is it
also
saved?
yeah, it is saved. Yes, let me show it. It's already 1 minute. Let me say where it says that it is saved. Okay. So let me just look at that. First let me try what is there in EXP experimental. You see two directories, and in the first directory it is to do with the MFCC for train and test. It has lots of log files and things. We will not worry about that. We already talked about Kestrel mean variance normalization here. This is a log. We will not worry about it. Let's now come back to the EXP. Let me see what is there in the. I'll go to the mono. Let's see what is there. If you see here, there are some files with the extension MDL. It is model file. Is it an ASCII file? No, it isn't. Let me just check that. The data, it's a binary, all zeros and ones. It's actually model is stored in a binary format.
Acha. And
Okay.
all the rest of this OSSCS files, are they a part of the model thing or they are something else only?
Okay. No, there are two models here. Okay, only two models. 0.model and 40.model. 0.model, the initialization part. Okay, monophone training, initializing monophone system, 0.model. And there are how many passes are there? For 39, 40 passes. At the end of the 40 pass, whatever model is there, that is stored here. So this is the final model that will be used for decoding. In fact, there is a link here called final.model, which if you see ls space minus l final.model, it will point to 40.model. ls minus l, sorry, it became. Can you see?
Okay. So this is basically like a soft link, right?
It is a soft link, exactly. It's a soft link. Because what happens is sometimes, okay, now since we are at it, let me just go to the WER error. Which is better? Lower the error is better, lower the number is better, or higher number is better?
Lower number.
A lower
So
number.
lower,
Correct.
lower.
I'm just okay. I'm a teacher, no? I have to ask questions of this type. Most of us are teachers.
There are some insertion, deletion, and substitute.
Yeah, the description will come. Yes, we should talk about that also. But let us look at the one number. Which number is lowest? Here is 6, here 7, here it became 8. Which number is lowest? Some 5s I see, so I'll concentrate on the 5. This number is the lowest. Can you see that?
Yes, sir.
Okay. Now, this number is lowest for this particular configuration. What is this configuration? It says that word error when the system was trained with 17 passes and the language model weight is 1.0, word error rate was 5.87, the lowest. Therefore, it is best if I use these parameters. No, I will not train the system 40 times, 40 iterations, but I will take the model called 17.mdl and I will use it. It helps us to do that. So if I want to henceforth use the final dot model as not 40 dot model, but as 17 dot model, I can put the link. Of course, it has deleted the older models, but it can be stored, restored. That is where this link will help, because while decoder will always look at this final dot model rather than 1 dot model, 2 dot model or something.
So as you said, it is a 17 pass per thing. So that means it did that 17 times, or it took the first 17 sentences? I didn't understand
Okay.
it properly.
Okay. This is HMM training. You take entire training data. You initiate the HMMs with some arbitrary value, something like, arbitrary, not really arbitrary, but whatever it is. Okay, some initial values.
Right.
And re-estimate the parameter of the HMM. HMM re-estimation is primarily transient probabilities, but means and variances of the normal distributions.
Okay.
So you
So
use
that
all the training data and re-estimate. Then the one new version of the model is created. This is called one pass. Let me repeat it. We start with the 0 dot model, which is almost random. We use the entire database and train it once using the expectation maximization algorithm, training algorithm. We get a model called 1.mdl, which is obviously better than 0.mdl because it has seen some data. And do this. So each of them is called passes. And typically we know that it requires at least 5 passes or 7 passes. This also can be set in the run.shell. So they started showing, while decoding, they started using only 7, 8, 9 models that are trained with going through the training 7 iterations, 8 iterations, and so on.
So
In
sir, we
each
can have
iteration,
like n number of passes, right?
Exactly. Yeah. This is the iteration index, right? Iteration index. How many passes?
Understood. So basically, this one gave us the highest, the lowest
Accuracy, highest accuracy
WR.
or lowest.
So that is
lowest.
why. So that is why we can choose this. Oh,
Now,
understood.
what I will do is I will set the maximum number of passes as 17 and stop there. I will not go all the way up to 40. This number is settable, okay, in the configuration. Okay.
So every time will it learn the same parameters?
All,
Matlab, like
almost
for
same.
first. Achha.
These numbers will not vary very much because, well, can it vary? Yes, because there is some kind of random initialization. But in our case, we actually do some rules for initialization. So I don't think this number will vary. It may vary due to finite precision and things like that, but no. There is no random initialization in the sense of in some cases. Here, here everything is sort of set, I guess. I mean, yeah, minor variations, but really doesn't matter. But in general, in iterative algorithm, you start with the random initializations, and some initialization do better. You know, gradient descent algorithm.
Yes.
Okay, now let me also, since we are at it, let me also explain the content of this line. Of course, this says that the information is there in the directory. What is that? EXP, monophone. It decodes recognition using the test diagram of the test data, and yeah, and and there is a file called WR. This is a file, you can look at it. We will look at it quickly. And I did a grep, so it showed only that line which is of interest to me. What does it show? Word error rate is 5.87%. It shows with the 2 decimal error, but I will stop at 1 decimal point because variation is even at this level. So it's 5 to 8, it varies. Therefore, this 5.8 is good enough for me. But anyway, let us see how this error number came about. Primarily, there were 480 sentences, and each sentence contained 7 words or something. So totally there were 4,480 words in the test data, out of which most of them were recognized correctly, but there were 260 were error. Therefore, the error percentage is this ratio into 100. This ratio into 100, which is about 6%. You can see that this is about 6%. You multiply this by 16, you will get this number. Okay, that's understood. Out of the 263 errors, there could be 3 types of errors. Some extra words were inserted, 114 insertion errors. Some words did not get recognized, they were deleted. Some words got misrecognized, or this is a substitution error. This is the way word error rate is calculated in speech recognition. If the output, so this is the word error rate. In Chinese language, there is no that concept of words are not separated by spaces. Therefore, they talk of character error rate, capital CER, in which case the similar concept applies. Any question on this line?
Sir, in case of yes no tutorial, there are only 2 possibilities, yes or no. That's why there are 0% of word error rate when we run.
Yes, and also it is by one speaker.
So it is insertion and substitution. Those are very least probable because only there are 10 digits are there. So it can be replaced by other 9 digits.
Correct.
Or deletion it can also be, or substitution. So when there will be lots of words will be there, suppose we are handling with 10,000 or 1,000 words, then their word error rate may be increased without the proper model.
Exactly, and somebody actually said that they tried with their language, word error rate was very high and things like that. But that's where, of course, we will. That's the improvement of the performance. But
So
you said 2 points. Why the word error rate is higher here and nearly 0 there in the SNO? 2 points. One, in SNO, at any point in time, only 2 words are possible. Whereas here, at any point in time, any of the 10 digits can come. So this is there's a measure for this confusability. So the confusability there was between 2 words. Here there are 10 words. Therefore, we say the perplexity is 2 in SNO case and 10 in our case. It is not the number of distinct words in the language, but here in this case, at any point in time, any of the digits can come. Whereas in the natural language, even if there are 10 words, we follow grammar rules. Therefore, there are some linguistic constraints that come into picture, that grammar rules are non-existing here. Therefore, the error rate, perplexity is 10. Okay,
So
that's it.
that means whenever someone is writing some paper, suppose we are saying that there is a word rate of 9% or 10%, but I have a word rate of 20%, but that doesn't mean my model is not good, because if I am taking all possible words in that particular language, and if someone is taking only 20% possible word of that language, then his word rate will be reduced. So that means whenever we are putting in some word error rate or efficiency, we should mention how many distinct words we are taking.
Exactly. So whenever see papers, always at the end of the experiment there is always a discussion. Okay,
Yes,
experiment results and discussion. Discussion is a separate subject. Then, of course, reviewers will demand that you show me how does your system compares with the other systems. Of course, you will have to put a table. Don't put only error table, but also one number of words, unique words in the language, the lexicon size, and perplexity. Write it there, because many guys don't say. So here we use bigram. You can use trigram and various other things. Perplexity slightly reduces. In some cases, you write the perplexity. Also, you write the number of speakers.
Yes.
In yes/no system, there is only one speaker.
Yes.
Here, there are 8 speakers. Number of speakers more, variability increases.
Yes. Yes.
And then is it recorded in quiet condition or normal natural conversation? Of course, it will make difference. So whenever you want to compare two experiments, you need to give all these conditions, and then you should compare. Scientists will agree with that. But if you just give the word rate, some guy will say your word rate is 20, that guy has given you 10, so he will reject. I agree.
Yes.
Okay. Without going to detail, I'll tell you one more, what should I say, tuning thing, some changes that we can make. Instead of using bigram, you can use trigram. Generally, it helps. That's the first point. Your word error rate comes down. So you can run this experiment after this session. That's one point. Second point is look at these errors. What we normally try to do is to set these two types of errors nearly equal. Now, let us compare the two successive lines. Which are the successive lines? These lines. Okay. One minute. Let's look at these two lines. The word rate is lower here and higher here, because this is 17 pass and this second line is 7 passes. Now let us compare the number of insertions and number of deletions. Here, number of insertions is nearly twice that of the deletions. Well, look at here, number of insertions is nearly 10 times that of the deletion. That is another hint, something that you can improve. How can you improve? There is some parameter called word insertion penalty, WEP. Okay, if you change the WEP, then insertions will reduce. So that is what is shown in these two lines. Let me now compare these two lines. Yeah. Note this line, word error rate with 7 pass. This is also word error rate with 7 pass. And this is also word error rate with 7 pass. Where it varies is something called word insertion penalty. WIP is a symbol that you will see in the code. These numbers change. Now, if this penalty is 0, there is no penalty, insertions are more, deletions are less. When the penalty is non-zero, 0.5, insertions reduce from 255 to 237. Insertions reduced by how much? 255 to 237, by almost 20, but deletion increased by 2. Still it's okay because my insertion reduced by 20, deletion increased by 2. This is better. Therefore, the error rate should be smaller. Yes. Just by increasing the word penalty, my error rate reduced because insertions were very large. They reduced, slight increase in deletion. Now let us go to insertion penalty 1.0. Let's be a little bit greedy. Then number of insertions reduced further from 237 to 225, about 12, and deletion increased by only 1. Obviously, this number is lower because the total error rate is smaller. Any question here? Okay, I have a question to you. Why stop at 1.0? Why not make it 1.5? Probably it will reduce further. कर सकते हैं. That is what you should do. Okay, that's up to you. But what has been done in the shell script is by default, they decode it with the 3 word insertion penalty because these are the typical ranges. Again, this is something that you need to tune. Why only 0.5, in terms word insertion penalty in terms of 0.0, 0.5, 1.0? Why not 1.1? Why not 0.7? Of course, करो. तुम्हारे पास lab है, PC है, run करो, find out. Plot it as a function of word insertion penalty. You can do all these things. In a thesis, you will write all these things. In the paper, you do not write it because this is a standard procedure. So I showed the word error rate for 3 word insertion penalty for pass 3 because and you saw a significant decrease in word error rate for different values of the word insertion penalty. What about for the best number of passes? 17. If I change from 0 to 0.5 to 1.0, it changes slightly. It still has, so word insertion penalty has to be increased. It will reduce by what? कितना ज़्यादा नहीं है, 6.16 से 5.92, 5.17. So it changes are in the first decimal place. And actually, change is 0.05 still. Okay, if you want, you can do it. So I'm talking about the tuning things that you need to do, which is obviously that visible here, can be done. Where to go, where to change it. Of course, you have to go through a little bit of scripting, and they will all be there somewhere at the high level that we can talk about it later in another session. I also don't remember exactly where it is, but I know I can go in and find out. Okay, that is the first point. Second point, here, these word error rates are low because our test data is the same as the training data. Why did you do that? Because we had very little data. If we split it up into test and train, then we will not have enough data for even training models. That's why we did that. But when you report results, nobody wants to know. Well, I shouldn't say nobody wants to know. There are some places where you need to know, but the accuracy on the test training data. But when we report the accuracy, you generally report the accuracy for unseen data, data that has not been used for training, that is test data. By convention, test data means it has not been used for training. That is why when I said in the README CLST, let me go to the beginning of the file. I specifically talked of 2 types of transcriptions, one for test data, one for training data. So there's the same file ID should not be there in the both of them. So the content, file ID is here and test and train should be distinct. You should report the decoding always takes place for this. Therefore, you should, in general, you should divide the data into at least 2 parts. Generally, I take generally 2/3 part for training and 1/3 for testing, and then do a threefold cross validation and so on. Those are the details. That information actually is there at the end. Where is it? Yeah. So we have done this. Sorry, let me now go back. We have done the step number 2. Step number 2. This is step number 2. This is already done, and we were inspecting the word error rates. Now, of course, you can do this also and run it. You do it later. And then some descriptive notes are here. Notes of manual interventions. Splitting of the training speech data into train and test part is a manual task. Depending upon the number of parameters, divide the text into 2 parts of this thing. Yeah, mutually exclusive speaker sets. I talked about that. There are some extra things that what are the words which are confusing and so on. There are some scripts for that. We'll talk about it little later. Today we'll. So we have this third part. I assume you can do it on your own. So that's not an issue. So let me go to I guess this is where I want to stop today. Any other questions? Yeah, Sajal.
Hello, sir. Suppose normally we take, as you said, 2/3 or 1/3, means 30% and for testing, 70% for training, or 40/60 or 20/80. But suppose we have less amount of data, so we can put some extra noise on that thing and we can use it to increase the volume of the data. Is it possible?
Yes. In fact, yes, you are perfectly right. Your thinking is in the right direction. Suppose I have only 1000 speech files. That is nothing. So I use 300 speech files for testing and 700 speech files for training. Now, to these 700 training data files, I can add a little bit of noise and reduce the SNR. Then I have 700 plus 700. You give all these 1400 files for training. Then my system becomes a little bit robust to the noise. Yes. Still, the sentences have not changed, words have not changed, speakers have not changed, but you can. This is called a data augmentation, augmentation. And the beauty, so you are thinking the right direction. You are in the group of several other people years before you who built the Kaldi model. They also thought of this, and data augmentation is now a standard parameter in Kaldi. You can just set it to data augmentation. Okay. It will add it automatically. Okay. Those guys they're nice guys. Whatever good practices are there, they have already put it there. Now, where is that switch? Of course, right now I don't know. And people who use in industry with the when especially for TDNN, I mean, when you use recursive neural networks, you need hundreds of hours data, 1,000 hours of data, and so on. So the data augmentation by adding noise also, you can add reverberation noise, you can add white noise, you can do the what is that called, vocal tract normalization. It is person has spoken and with this pitch, my pitch is 140 hertz, you can artificially increase the pitch by, let's say, 20%. It becomes 200 appears as if a female is speaking. You can do this pitch variation. That's also data augmentation, but more frequent data augmentation is called speed variation. People at my age tend to speak slower. I'm speaking fast these days because I want to finish it off. But otherwise, generally, elders, they speak very slowly. So different people speak slowly, fast. So some speech is there, you can increase the speed by 1.1 or multiply it by 0.9, so reduce the speed. So this is again speed variation perturbation. Speed perturbation is standard switch in Kaldi.
So some speakers are like extraordinary, like Atal Bihari Vajpayee.
Exactly. Yeah, they think a lot, and politicians in general speak slowly. Do you know why? Not that they can't speak fast, but
Without a slip of tongue, some words will come which may cause their some controversy.
आजकल WhatsApp भी है. Yes, various
For
funny
that
things.
controversy, because that's why Atal Bihari Vajpayee never in controversy, because he can think, he can write, then he can speak.
That is true. And there is a other reason, which is the people who listen to his talks, we go to election rally, are mostly people from village, rural area.
Yes.
They cannot absorb information fast like we people do. No, you are used to speak very, very, very fast and all those things, you know. So that they have to absorb there is enough time for cognitive absorption. There is no cognitive overload. Anyway, ठीक है. Any other question or comment?
So what was there before Kaldi? Was there ASR before Kaldi or
Of
Kaldi
course.
only?
Hey, come on. Hey, you poor people like me, you are ignoring me, huh?
Yes, sir, that is what I want to know.
Toolkit.
What toolkit?
HTK.
HTK, correct. And before that, let me just go to the, okay, HTK, okay, Hidden Markov Model Toolkit, HMM Toolkit. This was built by a PhD student in United Kingdom, Cambridge University. He built it in around 97 or something. We built it, and 1995. And 1995, he built a company called Entropic, okay, and it became a commercial system, and they were selling it. And in fact, in TFR, this is 1993, acquired the right. So it was written in early 90s, 1993 company, it became, and TFR, we bought it for 2 lakhs or something in early 1990s. Remember, that 2 lakhs is like about 2 crore now. It was expensive, but we wanted to do research. So, and fortunately, I was in a national laboratory. There was a United Nations project, so we could buy it. Otherwise, we will never buy it. So we used it. I used it for about 2 decades. Only in the last 7-8 years I have been using Kaldi. Anybody asking question what was there before HTK?
Sir, I would like to know, but yes.
Good. Anybody knows? Have you heard this word Sphinx in Egypt?
Yes, sir. Carnegie Mellon, CMU Sphinx.
That is in US, man. This is in yes, you are right. Sphinx. So let me go to the Sphinx. This is showing something else. Sphinx CMU. Sphinx CMU models. Okay, models. That's also open source. That started with the open source. It remained open source. And this again was outcome of a PhD student. His name is Kai Fu Lee. He was of course, Chinese student working at School of Computer Science in Carnegie Mellon University in Pennsylvania in US. And he submitted his thesis in 1986. And in the year of 87, I visited Carnegie Mellon University. Let me do some what is that called? Backpacking. I visited the CMU because thanks to Professor Raj Reddy, who was the head of the department, he actually won, what is that called? The Computer Science Nobel Prize. He won that for speech recognition thing. And so I was one of the first few people who used Sphinx model, that was Sphinx 1. And I built a Hindi speech recognition system. Udari data collect here, there were some 5-6 Indian speakers were there. I asked them to read some Hindi sentences, built, and I called it as Dhwani name. Anyway, that's so. Now that probably was the first HMM based model which was openly available, open source. And before that, there were HMM models in IBM. They were the guys who sort of popularized it, Rabiner and Jelinek, but that was at the company. Okay, that's the history. And let me also tell, of course, I was there only for 6 months and then I came back. And my colleagues, when I came, returned to KFR, there were a couple of colleagues, one Bhiksharaj, another is Rita Singh. So they are still there at CMU, they are maintaining the CMU things, but now it has become a bit, it, yeah, out, sort of out of popularity. HTK, some people still use it, but the problem with the Sphinx and HTK is that you have to do lots of steps, whereas in Kaldi, it's all automated. It's like Python programming. You write a C code, you have to write lots of steps. In Python, you call a library, get the thing done, forget it, kind of thing. So everybody likes Python, Python language, and everybody likes Kaldi. So now Kaldi is also sort of facing some, let's say, guys like OpenStep, what's it, Xstep Foundation guys. There is all going beyond this. Everything is TensorFlow and things of that kind. That's how progress is happening. And there is actually a session in interspeech a couple of months later where the future of speech recognition research will be discussed by experts. I got a email yesterday. If anybody is interested, I can share that link. Okay. This is blah blah. Next question.
So now, like last night, I was looking for various toolkits. So, sir, I came across ESPNet
Correct.
and SpeechBrain. These both are end-to-end model toolkits.
Correct.
The ESPNet follows a Kaldi-like thing.
Correct.
I think it is based on Kaldi, and it is in Python, so we can then use PyTorch and stuff there also. So I think
You are right. ESPNet is by the Japanese group, and yeah. So there was some recent paper also, some advanced version, and as you said, it is Python based, so you can download it and use it. But again, since it is end to end, you have to use the GPU. So whatever that also brings it to the point. Whatever that I showed here can be done on a laptop. I mean, because it is not sophisticated model, it uses a DNN. You see the DNN here. Okay, DNN switch. If you set it, it will use the DNN, but HMM is always there. So if you want to get rid of HMM and want to use the recurrent neural network, TDNN is based on that, time delay neural network. Then the computation increases. Therefore, one essentially goes to the cloud, or you should need a GPU. So what the purpose of this session was to have a base or a foundation where you can build a first level system on your speech database, and you can do it on your lab PC, whether you have GPU or not. Now, if you have a GPU, it is better to go to the Kaldi with the TDNN model, or ESPNet, or the later one as the other one, what is that called? SpeechBrain. But they require thousands of hours of data and kind of things. I mean, you can do the transfer learning, but that we learned it in the ASR school. So I am not comfortable with that. I heard, as I told you yesterday also, I heard lots of things, watched the entire proceedings of the ASR school, but I have not yet. I ran the DTNN for the data that they provided, but it is like pressing the button and getting some numbers. I had some problems. It was reran it. It worked all right, but I can say that I did the job. But if you ask me, can you do it? I have this alphanumeric number recognition system. Can you run it and that? I don't know where to put what. That comes by practice. And now we have a sort of group of half a dozen people at least who are actually interested in this group I'm talking about. Some of us will be more enthusiastic, more free time, or whatever reasons we learn, and we'll share that experience with others. and soon we need to go to the cloud based. That cloud, there is something that we can done freely, but may not be able to do, but you may have to pay a little bit. All those things will be the next part. But right now, I want all of us to be able to run a DNN based system, HMM DNN based system for our database. Now, the advantage, why we are running all these things, because all our checkings that we were doing, check lexicon and other things, they will take care of many errors that are there in the wave file transcription and so on. Therefore, then if you run it on the ESPNet or anything like that, it will be very quicker. It will not waste some speech data.
Sir, I have a question.
Yes.
Sir, suppose we got word error rate and all these theoretical. How will we implement it, sir, for real life experiences?
Do you want to build an app?
Uh, App or online system, sir, as we witnessed during session, sir, that we spoke some Hindi sentences and it got executed. We got an output like Hindi sentences. So
Yeah.
how we implement that? We got a theoretically WR rate, वगैरह.
Sorry, let me go back to the, now I'll move out of this place. I'll go to my 21 directory. Let me see whether I'm in the 21 directory. No, I am in AS. Do you see a word here, demo.shell script?
Yes, sir.
Ah, if you want, we'll have 5 minutes, 3 minutes look at that. Let's look at that. That is meant for showing a live demonstration. Suppose we have a model here, then you want to run the script, speak a sentence, and see the word getting displayed on the terminal. And either. It's a variation of the run.shell. Okay, what I did is, let's look at that. It's only one speaker, therefore I set it clear, because single test file. MFCC switch, yes. Testing, I'm not going to do any training. All the training switches are set to 0. I will run only testing because I didn't put the DNA, this also can be set. So I can test the output using various models, monophone, try 1, try 2, try 3, SGMM. Generally, try 3 works good enough. Therefore, it's good enough if you set this switch to 1, try 3, test switch to 1, all other switches 0. That switch and signal processing, of course, it has to. Whatever you speak, it will be recorded, it will be MFCCs are computed and decoded using the triphone model. Okay. So demo.c restive. But notice here that there is a stuff here. Record de novo speech. By default, I have set it to 8 seconds. Kidhar hai 8 seconds, idhar hai. You can change it, up to you. Okay. So what it does is you uses a sock command called rec. Rec would nowadays it's the socks is by default. Rec will be command there. It records it for 8 seconds, and it is recording for this. You should change it to your 16,000 or whatever it is. This is the sampling frequency, and it generates the speak to art to speak and all nonsense things. It runs the MFCC extraction and decoding, and at the end, it monophone testing. It shows the sentences. There is an grep. It will put it. It does various things at the end. Testing is over. It just displays all the outputs, order rates and things like that. So essentially it is there, and but what you need to check is, change is, because this was from some other database, you need to change this to 16,000 and this to whether 8 seconds, 6 seconds, whatever it is. But in between, don't speak anything else. Once you press the enter, start speaking normally and just wait for the something other to appear on the terminal. That's it. So there is a demo is already there. Any other question? Yes. So you can show a demonstration. That's what I am trying to say. to you. Of course, this demonstration will show the words in English letter, ek is ek and so on. You can always, and there are other ways of transfer, printing it in Devanagari script or whatever script. Those are all trivial things. Next question. All right. So we spent 2 hour 15 minutes, 2 hour with the 10 minutes break. We spent about 2 hours today and 3 hours yesterday to have an overview of the usage of the Kaldi for a simple database. Things that you need to do next for people who had success so far. Things that you need to next is step number 3. That's one. And then you can, then I want you to repeat this job for your database. How will you repeat this job? Will you overwrite this? No, don't do that. So I'll talk about that and then we will break. And one person had some problem here. Let me try to resolve that. And one more person had a problem with the installation itself. We will look at that a little later. Okay, so now I am going to talk about how to implement a similar system for another language or even the same language but another database. Language doesn't matter, database is what matters. You know the requirements. I have put it in some particular form, okay, and I have followed some conventions. And I know that some people put the sentence digit as just 3, in which case you need to change these scripts appropriately. We went through the scripts. Wherever it is pulling out the sentence number, you should pull out appropriate number of digits. So little bit of changes are there. That's a database dependent changes. But where will you implement it? Where am I? I am in AS number recognition system, and I will go one step up, double dot. I am in chief directory. Now if you see, there's a directory called AS numerico 21, but the old one, database name, it is still there. I did not move it. I asked you to recopy it. Now this is why where is the readme number? You see line number. I did not overwrite the old one. So the old directory is still there, which means that you do not have to unzip it in again and again. You just redo this instead of AS numerical system, whatever language, Tamil numerical or AS database, whatever it is. And then go there. And of course, this contains the databases. That is your database dependent. After that, almost everything follows the similar procedure, but based on your file naming conventions, you need to take care of. You need to edit certain scripts that edit what are all the scripts. This script you need to edit. This you don't have to worry about it. Let me just show the scripts where you need to edit it. Data preparation. This you need to edit it because it is pulling out the utterance ID, speaker ID, and the transcription. And then you need to edit this. These are the two base things. Rest doesn't matter. Yeah, I think rest doesn't matter. Yeah. So these are these. What are these? One is this because it is database dependent. Another is this. This is also database dependent, means file naming conventions that you need to take care of. Okay, so if you want to do build it for another database, what you will do, you will start from here, cp -r. You already done the cd. The same. Right now, I am in the 0 chief directory. I will start from here. Instead of this, I'll give another name. You notice that I have put the language number here because I keep working in various languages. Even in a single language, there will be several databases. and this is my ear. Sometimes helps at my, not necessarily, doesn't matter. Any questions? And I also put these two files here. This is this README file is not the latest, but because I made some changes yesterday and today during our sessions, so I will also post it just for our references. I assume that you also have made the changes, so you can replace it. Any questions by anybody? All right, then what we do is, it is 8:21. We'll end the session. But Sajal, you don't log out because somebody has some problem, face some problem, and so please leave it there. And yeah, others can leave.
Sir, I also face some issue. It is not running.
Oh, you have faced some issue. Okay, who
Yeah.
else have faced some issue in running?
I have faced this.
Okay, now what I want to know is, whoever faced the issue earlier, first I want to attack it. In which stage Sajal faced the issue, and in which?
I face after MFCC when I change the monophone training.
Oh, okay. So from, instead of monophone, you went to the other one. That should be
After
trivial.
MFCC, I face the issue.
1 minute. Did you face the issue while training a monophone model?
Yes, yes.
Oh, monophone model itself, you face the issue. Well, what I will do is, please, other person, I just wait. This may be a trivial issue, so I may be able to solve. However, you need to show me the log file. See, that is why I assume that your errors are in the log file. So I will stop sharing.
Sir, after changing the switches, I think it's working fine for everyone, but maybe that he has not changed, he has not replaced it with that new one.
Yes,
The
you
log
may
file.
be, you
Yes.
quite likely. So let us look at his log file, and I will be able to. Yeah, you are right. That's why I want the log file. Let him display the log file. Thank you, Kim. Just we are at it. Kim, you are okay, right?
Yes, sir. Yes.
Okay, all right. So yeah, others can leave or wait. I have no problem.
Second, I leave. It's working fine till now.
Yes, yes. Everybody can leave now. Whoever has it has worked fine till the monophone. Rest is all fine. So all people for whom there is no problem with the monophone, you can leave, please.
Okay, sir. Thank you so much.
Okay. All right, Sajal. Show me the editor. Hey, it has run correctly, no? I thought it ran correctly. I saw the log. Ignore input failed command. You ran it from somewhere else. Run.shell. That's the problem. Okay, okay. Close it. Show me your terminal. Terminal. Okay. 1 minute. Yeah. Just to do ls. See, old programs are running. You should not rerun it without waiting for this step. That could be the problem. But first, let me check whether is there a run.shell. Yes, run.shell is there. Do a more run.shell. I just want to check that your switches are okay. More or gedit. Do you have it in gedit? Run.shell. If you have already opened it, show me that. Yeah, gedit run.shell. Switch monotrain switch is 1. Monotest switch is 1. That's correct. And you have saved it. This is fine. Okay. Now let's go back to the terminal. Now run that again. Come on. That 1 minute. Run it. It is running now because okay. Now you do the go to the gedit log that log mono.txt gedit log mono.txt. You have to open it. Go to the terminal. Gedit log. Right. Okay, return. Okay, let's go. Let's go down. This is all standard. Go to the bottom. This we have corrected. There was some problem. Was there a problem? No problem. I thought there was a problem. There isn't. Oh, it's running. Continue. Continue. Go down. Yeah, that's the end. So it is running. It will take a minute. It's running. Okay, now let me say why probably it got into problem. Because if you run one job when the other job is running, there will be problem. That is why people don't put that ampersand. I mean, if you are willing to wait, you don't put the ampersand and no hop, it will run. Right now it is still running. Press and enter. Now no, the one is still running. Your original work is still running. Okay, so what I want you to do is go to the gedit logmono.txt and keep refreshing. Reload it. See, it has changed. Reload. Not there. Right side. Reload. It has gone some more. Go down all the way down. So wait till the final WR comes. Then you are done. All right. Okay, Saja. So you are through. Okay, now who has the create language model problem?
Sir,
Yes.
I have problem.
Shantanu. Okay, yeah, whatever. Okay, please show me your error file. Then I will. Sajal can leave. Don't leave, but you can assign leave or leave it at it is. But you are free to stay, but you can leave if you need. Shantanu, please show me. Yeah, right. Good. Thanks.
Sir,
1 minute. Can you note down? I can see you. I can see. Don't worry. It's all right. This is good. Can you identify the error? I can identify. I can see the error. What is the first error? Yeah. What is the first error? That's correct. Correct. Yeah. No error. Show me where is the first. So this is a standard problem. Okay. You see, can you tell what it is showing? Which is the error? Highlight the error line. Yes. Command not found. So either you have not compiled some language model or this is not in the path. Okay. So let us find out where it is. I know where it is. This we faced yesterday. Somebody else also faced. FST add, right? Okay. Let's go to the terminal. Are we in the terminal? Let's go to the terminal. Okay. Fine. Now I want you to go to let us say CD space dot dot slash dot dot slash dot dot slash tools TOOLS. Enter ls. Okay, let us see. OpenFST is there. IRL is also there. Okay. ls space OpenFST space OpenFST slash bin slash not OpenFST 1.7.2. Sorry, probably. Tab, put it open at 1.7. Yeah, with that, there's a dash there also, right? Slash bin slash FST C star C and star is asterisk. Return, enter. Yeah, but what you now repeat the command with instead of C you put A. We had problem with the A return add loops enter. Arc sort is there, but add loops are not there. So it may be in the IRL STM. So let us do the following: ls space IR STLM slash bin slash FSTA star. return. Let's see whether. Okay, then
LS2.
LS, IRL, STLM. It's somewhere there, some bin. I don't know where that bin is. IRL, STM. Just enter. Return. Spelling mistake. Sorry. What is that? IRSTLM. Enter. There's a bin, but okay, but it couldn't find. Okay, let's execute the third previous command, that FSTA IRLSTM up. Yeah, instead of just remove the A. Star. Enter. So for some reason this add loops command is not, doesn't seem to be there. Something you didn't compile correctly, but let me just confirm it. So type in the following command: find, FIND, space dot slash space minus name space single quote FST star single quote. Enter. Okay, it shed something. There are too many of them. Repeat the command, but after FST put a A. A. Okay, enter. Yeah, it said some add loops or something, right? What it couldn't find, something it couldn't find. I forgot. Okay, CD space minus. CD space minus enter. Just single minus. Okay. PWD. I'm not sure where you are. Okay. Now let's go to the Kaldi CD space Kaldi slash CD Kaldi slash EGS slash Shantanu, whatever, zero Shantanu, yeah, whatever. Is it zero Shantanu? I don't know, whatever it is. Zero something. Zero. No. Slash AS, capital AS, slash capital AS. Let's go to the directory now. Tab will work. Enter. Now show me the error that it showed. I want to remember that error because I need to see where that error is. Show me that error message we got. Gedit problem.
So here I ran command number.
Yeah, but I can't see it. You have to, if it is in the editor, you have to share the editor again. Yeah. FST add self loops. I'm surprised. 1 minute. Let me see. Where is it in my directory?
Yes, sir.
Then we will know. FST add. It is not there. FST add self loops. Okay. Add self loops. No, it is not there. Who is asking for it? 1 minute. Prepare language.shell. Did you reinstall it? You said that you did it today, recently, right?
Today, yes, sir. Today only.
1 minute. And first, let's question. Did you write it to the same directory, Kaldi directory, or did you remove the old directory?
So I removed the old one and re-downloaded and reinstalled again today.
Okay. You removed the old directory, right? I just want to make, because that is something that I suspected. But let us see it. 1 minute. Let me just check on my terminal. Where does this FST add self loop seems to be required. Give me a few minutes. Let me check why it is needed and why that guy is asking for it. Let me do some investigation on my side. I am in, okay, zero chief. CD AS number 4 dot path dot shell FSP add FSTA report. It is not in my path. One. OpenFST and SRC FST bin. Okay, let me see whether that is there in the SRC FST. Let me just check whether it is still there. FST add self-links. Find dot minus name add self-link. Yes, I found it. It is there in the FST bin. FST. Okay. Now do the following: head path dot shell. SH and enter. It is there. So you didn't compile it something. Okay. Kaldi root src fst dot fst bin. I found in fst bin. No, I see src slash fst. Correct. Okay. Uh, type in the your what is that prompt is too long. So let me just shorten it at least for this session. Type in the following: capital PS1 equal to single quote dollar space single quote or double quote. Sorry, not double quote. Double quote. Previously also double quote. Equal to. remove the single equal to double quote. Enter.
Again here space, sir. After
no space. Just enter. Okay. Now, okay. Now that long prompt is gone.
Yes, sir.
You know, if you want this to be a permanent feature, I can tell you what you need to do.
Yes, sir. I want this Shantanu Administrator Think Center. This is very long, sir.
So what we will do is, I will let us do that first. Gedit. Gedit. Yeah, it should work. Gedit space tilde slash tilde. Yeah, slash dot BASHRC. Okay, enter. Now show me that your gedit. Yes. You go to the end. Okay, 1 minute. Let me just, I will tell you. Go a little bit up. Some more up. Some more up. There's a PS1 line now. Oh, these are the things that I gave probably. I don't know. Okay. Go up.
Yes, one here.
Now, this is the problem for all this damn thing. So, if you want just think, what I want you to do is comment the line 69.
This one, sir.
Yeah, that line. And add a line after 69. Enter. PS1 equal to double quote dollar space double quote. Okay, double quote. That's it. Save it.
Yes,
Okay.
sir.
Next time onwards, it will always be dollars. Okay, fine. Okay, let's now we can ignore this. You can close this, and we'll go to the terminal. Give me a minute. For some reason, you are called. Okay, let's check whether it is there. Type in the following command: ls space double dot slash double dot slash double dot slash src slash fstbin slash fsta star return. Do you see that self-add loops is there, but the CC is there, source is there, but the program is not there. That is because you have not compiled it. Somewhere you did not do the step properly.
Yes,
so, yeah. So what we'll do is the following. Type in push D, PUSHD space double dot slash double dot slash double dot slash src. Return. Enter. Okay, now we are in the src directory. And now there is a make command. More install. Let's see what is there in the file. More MORE space install. I capital, right? Capital I. Tab. No, all are capital I guess. Tab. Return. Okay. See, there are some commands here. For some reason, not everything has been done. Okay, whether you did it in the tool install that you are supposed to do first, let us do this installation again, because I don't know. I mean, if there is a problem there, it will flows here. So we'll spend some half an hour in just running through. It will not recompile probably because it is already recompiled. So let us go to cd space dot slash tools return. Okay. More install. Same earlier command. You can repeat the earlier command. Return. Okay. Enter. Q. Just type in Q. So let us run this check first. This is that command you run it. Extras. The top command. Extras. Yes, that one. Right. Copy paste. Okay, good. Now let's run the make. Yeah, I don't think that will matter. No, it may not matter. I don't know. Okay. Now you need to run it. I don't know. If I ran just like that, let me try make. Just make. because we don't know the, I don't know the, just, it will take some 15 minutes to just check that everything is okay.
Warning, sir. This is
No, it will
there
not.
was this warning, sir.
Relinking, that's okay. Relinking is, there are already a link, therefore it will be leaving. What I should have done is to put it into the log file and see whether there is some error messages would be there, something would be there. IRSTM, you already installed it, right?
Yes, sir. Sir, it is there. IRSTM is not installed by default anymore.
Yeah, so we just run that command just for the copy extras install. Last but one line. Yeah, that one. It's okay. Just it will probably do it. Yeah, I don't know whether you did it. Did you do it in the morning? Oh, it's
Yes, sir.
already. Yeah, it's already did it. Therefore, now let us check that again. Okay, cd space // tools. Enter. There was a ls command that we looked in. What is that fst bin? Can you go up? Okay, don't do it. ls space fst bin. Oh no, it was in src. Sorry. Delete this command. cd space / src. Enter. ls space fst bin / fsta star. Enter. It has not compiled. Okay. Now let us cat install or more install. Yeah, anything. Yes, tab works. Okay. What we need to do? Now let's do the these three commands. Dot configure -- shared. Yeah.
Sir, all together.
No. One by one. There may be error. I don't know. Warning. Wait. Let me see. That is okay. I don't think so. Kaldi is successfully configured. Okay. How many cores do you have?
6 core, sir.
Okay, so you can make depend one by one. Yes. It doesn't matter. Let it be. It doesn't matter. It's return. It's just checking that everything is okay.
Yes,
If something is not okay, it will compile it. Okay, there was one more make command. There was a lot. No. Sorry, is it just make? I don't.
No,
Cat install more install. Well, I just want to be careful.
look at there, sir, only, or
No, type in the following command. More space install. It's just to make that command. Let's also put it will run faster. It seems to be read error. Something was there. We'll see. We may have to rerun it again. There was some error was there. That's why I run it to the. I always redirect the output into log file and inspect it. Anyway, let's wait. Oh, it is doing something. It is downloading something. So something was not done properly, probably. Probably the last make step you forgot. There are some errors, right? It's okay. Let's press and enter. It's still doing it. It's still doing it. Let it do it.
yes, now
Okay. Now let us try that command. ls what is that? Fst bin or something. Upper command. Go back. Arrow. Yeah. Enter. it has not done. Therefore, there are some errors we need to repair it. So now you do the make, just make greater than ampersand log.txt. Return. Just wait. Let's let it. It will take 1 minute. Let it complete. Then we will inspect the log.txt. Something is not right. I saw some errors, but I was not sure. But let us see.
Sir, actually, I installed Kaldi at 2 p.m. only, so I didn't have permission to open the office. So I came here at 2 p.m. So in hurry, I reinstalled again, sir. Might be I did some mistakes.
I don't know because we redid the installation in the tools directory. There was no problem. Don't
Yes,
worry. Oh, you are in the lab, is it? Okay.
yes, sir. Office lab, sir. It's
CAL,
Sunday today.
CAL office. Okay.
Yes, sir. Yes, sir. It's
Ah,
Sunday today, so no one is allowed. But I allowed. I just informed that I have work after 2 p.m. So
ah, ah.
I have keys of my office. So I'm here only.
Oh yeah, yeah. I have been to CAL, so you have to make
Yes.
an entry, permission, and all those things, usual things. Yeah.
But sir, computer section is not open. I have been provided a separate office, separate room,
Okay.
uh,
Okay.
that separate computer system. Naran sir has provided all those facilities.
Very good. Where do you stay? Are you?
And the hostel only, sir.
Is the hostel on the campus? I don't know.
Yes, sir, inside campus, sir.
Okay, that's good. Okay.
So I can work here till 9 p.m. So 9:10. It's my choice, sir.
Yeah. Yeah, it is choice, but it is also responsibility. Yeah,
Yes,
both.
sir. Yes, sir. Big responsibility. Huge responsibility.
Yeah.
Computer unit is closed till at 5:30 only, sir.
Yeah, see, they are, yeah, regular 9 to 5:30 job
Yes,
guys.
yes,
Yeah,
yes,
poor
yes,
guys
sir.
have to go home.
That's why I sir connect by both the ways, mobile and system, because system does not accept my voice audio calls, so I'm not able. So whenever I have to talk, I connect by both ways, desktop and mobile.
Oh, right now, Meet is it? Google Meet is it?
This is Google Meet. For
Uh,
audio calls, I connect by mobile,
uh,
and for a system of my this work, I connect
oh,
this desktop.
why system does no permission to use the audio? Is it
And
maybe?
sir, I was trying during a workshop also, summer school also. My name was being called, and I was not able to respond.
Is this the security aspect of CAL?
No, sir.
It's
I,
it's a problem with your laptop or?
yes, I have asked to the technician over here
Uh,
to check the issue what, because I have to connect by both ways. So I face this.
so it is a problem with your audio card on the on your desktop
Video.
PC. Okay, yeah,
Yes, sir, yes, sir.
and that's okay. Yeah. Somebody will correct it. All right. Okay, Shantanu, yeah, it's still running. I
Yes.
am little surprised that it's still okay. It will take a minute, but let's wait. So this is your what, fourth month in Karnataka, Mysuru?
No, sir. 6 month. 6 months
Ah,
already have passed. I
oh,
came here during second week of February,
ah.
and since then I've been here only.
Yeah. So how many Kannada words do you know?
Uh,
More than
I
six?
started. Yes, sir.
Ah,
First, I started learning Aito, and then
ah,
doing
ah.
Tindi,
Tindi.
Uta. Yes, sir.
Uta.
Uh,
Yeah. Mm. Well,
Howda. Howda is
Howda.
the most important I have learned. Howda.
Yeah, there is a tone also.
Yes, sir. Yes, sir.
Mysore tone. Yeah. See, within CIL, doesn't matter. It's a national institute. But
Yes.
when you go out in the bus or any town or anything like that, Kannada.
The first day, sir, at University of Mysore, I faced this language issue. I was there for an inquiry of my PhD admission.
Yeah,
Sir
yeah.
usually sends me, so go and inquire about the process. I went there and I was asking in English. By listening my English, they got that he's not Kannadiga. So okay, their response was like, "What should I share, sir?" First experience. But that's the best thing I experienced here, that people value their mother tongue at the most. In my Bihar and all, people hide the English language the most. But
वो
here,
इंग्लिश लैंग्वेज जॉब मिलता है इसीलिए काम के
इसलिए
लिए.
सर, but sir, mother
Again,
tongue.
but I will blame educated people. People who want to educate, they want to learn English at the primary school, KG onwards.
सर बट
If the
दिक्कत ये है ना, इंग्लिश को एक लैंग्वेज नहीं रह गया, एक प्रेस्टीज बन गया सर, इसलिए थोड़ा सा हो गया है.
वो तो है जी.
अगर कन्नड़ा नहीं जानते हैं तो मुझे शर्म नहीं आती है, लेकिन इंग्लिश नहीं जानते हैं तो शर्म आनी चाहिए, ऐसा हो गया सोसाइटी में.
है वो बड़ा शहर में है, छोटा शहर गांव में कम है मेरे ख्याल से, मालूम नहीं.
गांव में भी है सर, अगर इंग्लिश बोल रहा है तो पता नहीं दूसरे प्लेनेट से आया है, ऐसा सीन है सर हमारे इधर बिहार में तो और खास
है. भारत में सभी जगह है, लेकिन या ज्यादा कम वो तो होता है.
मुझे यहाँ बहुत अच्छा लगा सर कर्नाटक में या फिर साउथ इंडिया में कि लोग मदर टंग की वैल्यू करते हैं. दैट्स ग्रेट थिंग एज अ लिंग्विस्ट सर. मुझे
आप लिंग्विस्ट है इसीलिए
सर, इसलिए सर.
Okay, मुझे अभी now I'm looking at your terminal, whether it is running or not, I don't know. Can you open another terminal and check another terminal? There are of course multiple ways of doing it, but you can. Are you in the same terminal?
Yes, sir.
Okay, you put Control Z and then type in BG, return. Okay, now you put a top, TOP. It's running in the background. Enter. I want to know whether it is running or not. CC1, it's still compiling. Yeah, it's still compiling. Okay, Q, type in Q for quit. Okay, now gedit, whatever log file that we have created, I don't remember the name of the log file. Is it ls? Ls will tell you. Just log.txt. Yeah. No, don't do anything. Just ls. You type in ls, it will show you the log file name. Ls, return, enter. It's a log.txt. gedit log.txt. Yeah. Show me the log.txt. There may be errors there. Let's check that. Yeah, it's coming. Change on, you can reload it. Okay, let us go down and see where the first error occurs. We have to go page by page. You can do a Control F and error. ERR uppercase. Control ERR uppercase. No, just ERR, not complete error. ERR. Search? No. Okay. So far, no. Okay. 1 minute. WAR, warning ka, first letters. Lowercase, uppercase, anything, nothing. Lowercase, try lowercase again. Oh. Okay, no. Okay, fine. Then close that and reload it. Because now let us try it again. Warning or error. Normally I do a grep, but that's so Control F. That's simpler. No. Okay, error. ERR. No. Okay, so it's running. I do not know why it is running. Let us see. Wait. Let's go to the end. Drag it to the end. Let's see what. Just drag it. All the way down. It is still compiling. Open FST. It is compiling. Let us see. Why it didn't compile earlier, I don't know. But let us see. Change on this. Reload, reload. Let's go to the end and see what it is doing. Open a first step. Discriminating. Check in the terminal whether it has come back. In the terminal, press and enter. If it has done the job, it says over or something. It says. On the terminal, just press enter. Just ordinary enter. Just.
Yes, sir. I pressed enter and dollar sign. Yes.
Okay. Then it is still continuing because if the job completed, it will say completed square bracket number one completed something. So it is still running. So let's come back to the log.txt. It is still running. Let's wait. Probably for some reason, for whatever reason, some things were not compiled, so it is compiling now. It appears like that because it is taking more time, right? Now?
Yes, sir.
Because when we ran the make command earlier, it did not take this much time, 1 or 2 minutes, yes, but this has taken 5 minutes or more.
Yes, sir.
Okay, let's wait. I'll come back after. I'll
So
come
much
back after.
patience you have, sir.
Pardon me?
So much patience you have, sir. Thank you so much, sir.
देखो शंतनु,
Yes, sir.
रिसर्च में ऐसा चाहिए, नहीं तो रिसर्च नहीं चलेगी. वो अभी आप क्यों आया है इधर संडे को छुट्टी के दिन? हाँ वही वो CALTF और ये नेशनल इंस्टीट्यूट है, रिसर्च इंस्टीट्यूट है, ऐसा चलता है, IIT में चल रहा है, इसलिए मैं हूँ. लेकिन एक अच्छा क्या है कि मैं IIT मद्रास में भी था 1 बरस, और तब प्रसन्ना सर थे, वो उधर वो PhD के लिए आए थे, तो अभी भी याद रखते हैं वो. So it always comes back. This is why I like sitting in the lab with the PhD students and project staff than sitting in the office room. That's okay. So I'll come back after 2 minutes. Okay.
Yes, yes, sir, yes.
हाँ मैं फिर बंद कर 2 मिनट. Yeah, I am back and
यस सर,
I.
दो जगह इसमें एरर है, और टर्मिनल में भी सर एग्जिट आया, एग्जिट 2+1।
That's okay. Where is the first error? Let us see that. Let's search because we shouldn't look at the last error, first error. Search for control. Search for ERR or yeah.
दिस इज द ओनली।
Okay. Is there any warning before that? I think I know. Okay, warning. No. Okay, I go to the error. Okay.
ओनली वन एरर।
Yeah, yeah. You see, what it said is that you said please download and install port audio manually. For some reason, it is not doing it. 1 minute. Let me see. Could not find tarball. Why it couldn't find stable version? Trying to download it via wget. Do you have any world web restriction on downloading somewhere or something? No, right?
नो सर, नो
Okay,
रिस्ट्रिक्शन।
okay, okay. So we'll do that. Now this is port space audio. Okay, so what we will do is you also do this because you learn this in the process. Go to the browser and search for that. What I will do is if this command. See, right now you are there, right? Install port audio manually. That command. That string. Install port audio manually. Let's copy it. Copy it and paste it on the Google search. In fact, I normally will also put the entire line, but that's okay. Let us see what install port audio manually. Actually, I should say Ubuntu, but that's fine. Manually port audio manually cannot open something.
Oh, you are not looking at it, sir. You only log file is visible to you.
No, that's okay. I don't care. But I'm also doing it here. Ubuntu.
Yes,
How to install port audio in Ubuntu? I'm just looking at that. How to install port audio in Ubuntu? I got a Stack Overflow answer. I'm just going there. There's a code example also. Sudo apt something is there. Okay. What I will do is let me just because I like the answers rather than all the explanations. So see, I will copy the commands on the chat. That's what I found. So let me type it on the chat. There are two commands. One, first two lines are in a single line. Oh, you may not. On the terminal, you have to type in. Yeah, sudo, of course, sudo. Don't share the screen. Sudo, so therefore you have to put the password.
yes, sir.
See, that may be the reason for your audio problem. For all you know. Okay. One.
People install of my audio user.
Did it work without any problem?
The first one worked, sir.
Okay. Now type in the second one. Let us see. Second line whether it works.
Fully install my audio, sir. 0.2.11.
1 minute. Now you can share your terminal so that I can see what happened. Stop the sharing and share again. Share terminal again. Installed successfully. OP ho gaya. Now let us run the make again. Now let's go to the earlier command, make command. Let's go up. Put an ampersand. No. not this. Put another ampersand. No, not this. This itself. At the end, put an and sign. You know, and is shift 7. Return. Now enter. Now let us go to the log.txt because we are rerunning it. Now share me the gedit of log.txt. See, this was not there. There was some problem. Your audio had some problem. That's why you couldn't speak. Probably. It's coming. Reload. Yeah, it will take some time. Could not find. Okay, let's go down. That's okay. Wget. Still, let us go down. Did it stop? Oh, it stopped. 1 minute. What does the port audio do? See, then we can sort of stop that guy. How do I check that? Set up port audio and Pi audio in Ubuntu to play. How do I check that it has worked correctly? That's what I want to do. I'm searching in the web about the port audio. Okay. Let us go to this place because I see some commands for downloading. Let us see whether we can. PA stable V192011 is there.
Yes, sir. Sudo apt-get install.
But it is latest version is slightly different. Yeah, there is some installation commands. Yeah, if you go, where this Victor? Okay. There is a command on the second page. Sudo apt-get install lib sound dev.
Yes, sir.
Yeah, you execute that command. Let's see.
Sir, level sound 2 dev is already the newest version.
It already said that. Okay, now go to that, and this is step number 2. Can you see the step number 2? Yes, portaudio.com, download.html. Let's go there and let's download it. Just wait. Let me also see, because he is looking for, this guy is looking for some version, and we are downloading some other version. Portaudio.com, download.html. It is taking time to load.
Website not available.
What is not available?
Website is not available.
Yeah, it is extremely slow. Yeah. 1 minute. Let me look at your error messages. PA stable. Here is my suggestion. Copy that line number 92 in the log.txt. Download of PA stable. Last
22.
92. Yeah, right now I can see it. Last but 3 lines. Last about 2 lines.
This one, sir.
Yeah. Put it on the Google and see what happens. Just that line. Failed, including failed.
Okay, sir.
I
Okay.
need the Google will hopefully help. Did it give something useful?
No,
I
sir.
don't know.
Nothing like that.
No, did the Google search give you any? No, copy and paste
Sir,
it on
sir,
the Google search. It will give
sir, one
some
minute.
answers. Yeah, take your time.
Now this message is there. Hello.
Sorry, go back. Third version. Go back. There's a third choice. Kaldi. And further down.
This
Ah,
one, sir.
see? Ah, yeah, because this we are doing with the Kaldi. Click on that. Let's see what it says. Because, oh no, this install port audio or shell. That is a shell script. No. Let's go back. So somehow that go back to the Google search. Let me see, huh?
This one, sir.
Yeah, we can try that. Yes, because that's also GitHub, GitLab. No, that's also shell script, so that's no good. I mean, it will not. Now, for some reason, maybe because the site is not up, as we also try to do that, right?
Yes, sir.
Therefore, make could not complete that step, and therefore it crashed. This is my contention, my guesswork. So the only one way is to try it tomorrow. That's one. Okay.
Yes, sir. Yes,
But
sir.
before that, right now, let's go to the terminal and check for by our good luck whether that has been done already. Go to the terminal, share terminal. There was something like ls space fst bin slash fst a star, that command.
Yes, sir.
Yes, let's try that. You never know our luck. Oh, it
Again.
has not done that. Wait. Uh, uh, Type in ls and return. Let me see what is there. No, this is in fst bin. And we have what kind of FST? GMM bin GST plugin. Um, yeah, so CD FST bin, CD space FST bin, enter, ls, enter. Let us see. Just type in make, MAKE, enter. It is compiling. Let us hope that the audio problem is not serious and it is compiling. See, the make in the parent directory, what we were trying for 5 minutes ago, that got stuck because of the port audio problem. And because of that, it couldn't make it here. Hopefully, this make will do our job okay. Let us hope that. Let's complete this and then we'll go back to the our AS numReco 21 directory and run that bigram language model where we got into problem. We'll see. So anyway, even if this runs, tomorrow you will still come back to this SRC directory and run the make and hope that that port audio thing gets.
Yes, sir. Again, I'll do
Tomorrow that you can do, yeah.
tomorrow. Yes, sir. After office hour, after 6 p.m. Yes, sir.
Let me see. It did it. Just type in ls space fst a star return. Can you see the FST add self loops in green? Yes. So it has
Yes, sir.
compiled. Okay. Now let us try that this is good enough. Let us hope that this is good enough. Let us go to our directory cd double dot slash egs tab zero Shantanu zero tab slash as whatever. Return enter. Okay. Now we will run that make command that we had with the earlier make. Up arrow.
Make
No, not make. What is that? Up arrow. What were you running? We forgot now.
create background ls.sh.
That was where we are getting to problem. Right. Let's run that. Create. Yes. That create. Yeah. What command not found? rpart fst command not found. Okay, one more. See, this is the problem with the port audio. Can you see rpart fst? So let me just see. Where is that rpart fst? We are now doing quick fix. Rpart. Where is rpart to fst? I know it is somewhere. It's in LM bin. Yeah. CD space minus return. Uh, uh, 1 minute. CD space double dot. Enter. LS space LMBin. LMBIN. Enter. See there. Okay. CD space LMBin. We have to do. We are doing make. Enter. Make. Type make. Enter. See, all these makes should have been done because of that guy. It's not running. So of course there would be, we could have commented it, but I don't know. Let's do it. Okay, now ls, enter. Or put to fst there. CD space double dot. Enter. Ls. Now I want to check. Enter. What other make files are there? Let us see. I am looking at the various directory fst bin, HMM, right here. CD, well, wait. CD space LM. Enter. LS. Is there a make file here? No make. Yeah, there is a make file here. And has it compiled? It has not compiled. Yeah, just type in make. MAKE, return. Nothing to be done. Okay. There. Okay. Let us go back to our AS numerico. CD space tilde slash Kaldi. Tilde slash Kaldi, right? Yeah, Kaldi, I think. Kaldi, EGS slash EG. Okay, enter. Now let's run the create language model. हो गया. G.fst हो गया. Good. Okay.
तो थैंक यू सो मच सर. अब कल फिर से करेंगे सर, ट्राई करेंगे जितना स्टेप आपने किया है सर कल और आज में 2 दिन में.
कल आराम से कर देना. अभी 9:30 7:30 हो गया. घर जाके खाना भी खाना है. Okay, Shantanu, some other time we will meet and of course we'll continue this effort. Bye.
Bye sir, good night. Thank you sir.